Incredible news has recently spread across the internet. NASA has discovered evidence of a parallel universe. But is this actually the truth? Well, there is a grain of truth in this story, but it's not that simple. Let's consider it. Perhaps you've seen the articles that said NASA has finally found a parallel universe. This story was widely publicized, and people got divided into two camps: those who took this news at face value and those who considered it all complete nonsense. But both sides aren't exactly right. Let's start from the beginning. The discovery was made by NASA's ANITA. This name stands for the Antarctic Impulsive Transient Antenna. Yeah, it was designed to study neutrinos. Neutrinos are high-energy cosmic particles. They're incredibly small, lack any charge, and have almost no mass. Trillions of such particles pass through our bodies every second, and we don't even notice them, all because they almost don't affect ordinary matter. That's how insignificant they are. On average, in our entire life, each of us gets affected by a maximum of one neutrino. So basically, hunting neutrinos is like hunting ghosts. To catch them, you would have to send a whole stream of these particles through a giant piece of lead, and it has to be trillions of miles thick. At the same time, you have a 50-50 chance that you'll stop one of them. Therefore, in order to detect them, scientists had to come up with some clever tricks. We know that neutrinos, like other similar particles, come to us from outer space. Ooh. They travel to Earth from the Sun, stars, and even from the Big Bang itself. Some of them come to us from particularly big sources, such as black holes, supernova, pulsars, and even from various unidentified objects. Some of these particles have particularly high energy, and for scientists, these neutrinos are the most interesting ones. But oddly enough, most high-energy neutrinos don't actually come to us from afar. They form right here, next to Earth. This process has a cute name: particle shower. Well, this is how you can explain it in simple words. A granny particle gets into Earth's atmosphere. Usually it's a particle with very high energy. Then it generates several children that have less energy. Each of them then makes more grandchildren whose energy is even less than theirs, and so on, until we have a giant family tree of low-energy particles. In the end, there may be billions of them. During this process, piles of neutrinos are created. Then they begin to sink deep into our Earth. During their journey through the planet, they touch the upper layers of its crust or ice, for example, Antarctica's ice. When faced with all these obstacles, they create radio pulses, and as you might have guessed, these are the exact radio pulses that scientists are trying to find. It may be a surprise to you, but Antarctica is pretty deserted, you think? And that's why it's the best place to study microscopic particles, which usually can barely be traced. There won't be any interference or anything like that. We can catch these pulses with the help of powerful antennas. NASA places these antennas on balloons that can rise as much as 20 miles above Earth's surface. That's how they've been tracking these neutrinos for the past years. Alright, now we know what ANITA is doing. But what about that parallel universe stuff? Nah, don't worry, we're getting there. In 2018, ANITA began receiving abnormal radio signals that caused quite a stir in the scientific community. Remember how neutrinos come to us from outer space and then gradually sink deep into our planet? So, recently, ANITA has discovered neutrinos that didn't descend from space as usual, but rather rose up from Earth. In other words, these particles, called tau neutrinos, basically travel back in time. But how is this possible? Scientists began to research them. At first, they thought that maybe it was a detector error or an error in interpreting the data. But no, everything was correct. Something very exotic was happening. If so, then first we must try to find a simple explanation. What if these tau neutrinos just came to Antarctica from some other source? Maybe they came to Earth from the other side and somehow passed through the boundary. To test this theory, scientists decided to seek help from another cool neutrino observatory called IceCube. Yes, very cool. This observatory is located near the South Pole. It consists of 5,160 optical detectors buried in ice, And all these powerful detectors are designed to detect neutrinos. ANITA researchers were like, "Hey guys, we found some strange radio signals. Could you please check where they come from?" "No problem," Ice Cube replied, and started the research. And as a result, they found nothing. Yep, Ice Cube didn't detect any signal sources at all. It turned out that these strange particles had basically appeared out of nowhere. How could this be? Scientists tested many different theories, but none of them could explain the situation accurately. Later, Ice Cube published an article which basically said, "Nope, we have no idea where these signals came from and how to explain them in terms of the standard model of the universe." Oh, now it's getting interesting. So, what on earth are these signals? Having exhausted normal explanations, scientists began to consider ideas that go beyond our understanding. One of them said that perhaps these particles had come to us from a parallel universe where time flows in the opposite direction. This crazy-sounding theory is the result of the famous multiverse theory. According to it, about 14 billion years ago, when the Big Bang happened, two twin universes were born. One of them was ours, and the other was a parallel one. And they're almost identical in everything, except for some things. For example, time in this parallel universe doesn't move in the same way as it does in ours. It moves backward. Besides, everything there would look upside down to us, as if we're looking in a mirror. Therefore, scientists call it the antiverse, and believe it could be filled with antimatter. And even though all this may seem strange and crazy to us, for those who live in that antiverse, their way of life would be quite normal. In fact, they would rather find us, the strange ones. So these mysterious neutrinos could be born in this antiverse. Let's say they somehow existed there and then accidentally got into our world, where we were able to detect them. The idea of the multiverse itself is really incredible. If it's true, then it may mean that there is an infinite number of realities, many of which are much better than ours. Quantum mechanics even says that it's quite possible that every second of every day, any of your decisions divides the universe into two. And so there are quintillions of parallel universes where our lives have gone very differently. Something like this is hard to even imagine. Of course, it would be great if we could find a way to get into another universe, and if these mysterious tau neutrino particles were able to cross the boundaries of two worlds, well, maybe we can do that too? But unfortunately, this phenomenon alone isn't enough to say whether the multiverse theory is true or not. This is just one of several possible options. At this stage of human development, we cannot prove or disprove this theory. Maybe someday in the future we'll find out the truth, but definitely not now. The only thing we can say now, after this discovery, is that we've found strange radio signals which standard physics can't explain. So we need to move in this direction and study them to learn more about this incredible phenomenon. But people like to dream about space, so no wonder we've gotten so excited about this. And it would be great if one day it turned out that this theory was actually true. The theory of parallel universes has been popular in various movies and books for a very long time. Where would you go if you found out that you could travel between realities? Me? I'd look for a different reality of ice cream. Our universe is starting to glitch, and it looks like we're going through the biggest tension in astronomy since Einstein redefined gravity. But scientists aren't having a cow yet, because this kind of chaos usually means we're about to discover something huge. So let's run through the biggest issues driving the crisis. For decades, cosmology ran on the idea that the universe should look uniform in all directions for anyone anywhere within it. They call this idea the basic cosmological principle, not to be confused with the cosmetological principle, which states all women should wear a color of lipstick right for them. But I digress. Cosmologically speaking, it means you might see clumps up close, but on massive scales, everything should smooth out. Because of that, scientists figure no structure should be bigger than about 1.2 billion light-years. Yeah, that's big. So they were more surprised to find a structure called the Big Ring. This thing is nearly a perfect circle made of galaxies and galaxy clusters, and it's about 1.3 billion light-years wide. Now, a light-year is the distance light travels in a year, and since light is the fastest thing in the universe, that already tells you how enormous this distance is. If your eyes could see it, it would stretch across the sky like 15 full moons lined up side by side, see? And the Big Ring isn't alone. A couple of years earlier, the same astronomer spotted something called the Giant Arc, a curved structure stretching 3.3 billion light-years. Then there's the giant GRB ring, found in 2015, with a mind-melting diameter of 5.6 billion light-years. The Big Ring and the Giant Arc show up in the same part of the sky at about the same distance from Earth. So there's a real chance they're actually parts of an even bigger structure hiding in plain sight. Now, another scientific drama has to do with something called the Hubble constant. That is, how fast the universe expands, the connection between how far away an object is and how fast it's moving away from us. That number helps scientists figure out the age, size, and future of the universe. The Hubble Space Telescope determined that number with an accuracy of almost 1%. The universe is about 13.8 billion years old. So there was Hubble, and later the James Webb Space Telescope that measured distances to faraway galaxies and figured out how fast they're moving away from us. In everyday terms, they showed that for every million light-years you go out into space, galaxies move away about 45 to 47 miles per second. That expansion speed lines up nicely with a universe that's 13.8 billion years old. But there's another totally different way to measure the universe's expansion, and it looks way further back in time. Scientists study the cosmic microwave background, or CMB, which is the leftover heat from the Big Bang. It's the oldest light in the universe, released when the universe cooled enough for light to travel freely. When scientists use the CMB to calculate how fast the universe should be expanding, they get a slower number, about 42 miles per second per million light-years instead of 45 to 47. Now, that might not sound like much, but in cosmology, that gap is enormous. Both methods are extremely precise, and yet they stubbornly refuse to agree. This disagreement has a name, the Hubble tension. Right now, nobody knows why this is happening. Something might be missing from our understanding of the early universe. Now, just when astronomers thought it couldn't get stranger, the James Webb Space Telescope kicked the door down. It spotted some impossible early galaxies. These galaxies show up just 500 to 800 million years after the Big Bang. According to everything we thought we knew, galaxies at that age should look messy, small, and half-finished. But instead, Webb keeps spotting galaxies that look like they've had billions of years to grow up. They already show organized shapes like disks and bulges, basically the same structures you see in modern galaxies like the Milky Way. Features like that should take several billion years to form, not a few hundred million. It's like meeting a teenager who somehow has the wisdom of an 80-year-old. Now, in some cases, smaller galaxies seem to pack more mass than bigger ones, which also completely flips our expectations. Even cooler, some of those early galaxies contain heavy elements like oxygen and carbon. Stars make those elements, but stars need time to cook them up through nuclear fusion. Seeing heavy elements like that early is like finding baked bread before anyone invented ovens. Either the universe evolved way faster than we thought, or our timeline is missing entire chapters. Another weird headache in cosmology is all about lithium. Yep, the same element in phone batteries. According to the Big Bang idea, the early universe was insanely hot and dense, hot enough to smash particles together and create a tiny amount of lithium. Not much, but enough that we should still see about 5 lithium atoms for every 10 billion hydrogen atoms floating around today. Astronomers can actually check this by looking at stars. They use a trick called spectroscopy, which means splitting starlight into colors to see what elements are inside. Now, to estimate a star's age, they look at iron. iron only forms in supernova explosions, so stars with very little iron are super old, born when the universe was still young. But here's the problem. Those ancient low-iron stars barely have any lithium. Not just a little less, sometimes less than 1/20th of what the Big Bang predicts. And the older the star, the worse the mismatch gets. Scientists call this mess the lithium problem, and it's been haunting cosmology for decades. Some researchers tried to explain it by saying stars somehow destroy lithium internally. But every version of that idea crashes into other observations. Instead of getting better, the problem keeps getting worse. And when a simple element refuses to behave, it usually means our picture of the early universe still misses something big. Well, dark matter adds another dark spot to the picture. Scientists invented it to explain why galaxies don't fly apart. It acts like invisible glue. Models predict dark matter should pile up densely in galaxy centers and form sharp spikes. But observations keep showing smooth, soft cores instead. It's like expecting a mountain peak and finding a gently rolling hill. That mismatch shows that dark matter isn't behaving the way scientists assumed at all. Some of them even suggest dark matter might feel a fifth force, something beyond gravity, electromagnetism, and other known forces. That idea sounds wild, but it neatly explains why dark matter spreads differently than predicted. If it turns out to be true, it would change how we perceive the way galaxies form, how they evolve, and how the universe structures itself on every scale. And finally, there's dark energy that has confused scientists ever since they stumbled on it about 25 years ago. It makes up most of the universe, and we still don't know what it is. The default idea said dark energy stays constant, like a built-in pressure of empty space itself. Some theories linked it to quantum fluctuations, which are tiny particles popping in and out of existence in empty space. But when scientists calculated how strong that effect should be, they got a value trillions upon trillions of times too big. So clearly, something didn't add up. Now, a massive project shows that dark energy might not be constant after all. Instead, it might have peaked about 4.5 billion years ago and slowly weakened since then. If that's true, dark energy changes over time. Why does this matter? Because dark energy controls the universe's future. If it stays strong, the universe keeps expanding faster and faster until galaxies drift so far away we can't see them anymore, a scenario called the Big Freeze. If dark energy weakens enough, gravity might slowly fight back, expansion would slow, and galaxies that are currently disappearing could drift back into view. All these problems share something unsettling. They're systematic. They repeat across instruments, methods, and research teams. Random errors don't behave this consistently. The universe keeps giving conflicting answers, no matter how carefully scientists ask the questions. That's why researchers call this a crisis, not because science failed, but because it's working exactly as it should by revealing where our ideas fall short. A star is like a cosmic engine, crushing atoms together under insane pressure and blasting light and heat across billions of miles. Now, combine it with a black hole, a trap so powerful that even light can't escape it. The monstrosity you get as a result seems like stuff from science fiction, but might actually be a very real space object. When the James Webb Space Telescope started looking at the universe in 2022, it spotted something super bizarre. There were these tiny red dots scattered across the sky, and they were from times when the universe was very young. It was something no one had ever seen. So astronomers were totally baffled, but they still managed to cook up a few theories. So one idea was that these red dots were mini galaxies, but not your regular small galaxies. These would be only 2% the size of the Milky Way, packed with so many stars that it would make them a cosmic mosh pit. But that would be so dense it might just break the laws of physics. So this theory isn't very plausible. Could those dots be quasars, glowing, star-devouring black holes? No, they're too faint for that. And if a black hole that big existed in something so tiny, the galaxy would be like a backpack trying to carry an elephant. Not gonna happen. It's time to get acquainted with Avi Loeb, known for his pretty extravagant ideas about civilizations from other planets, and his teammate Fabio Pacucci. They think these little red dots are galaxies, but super tiny because they haven't even started spinning yet. Picture a baby galaxy still learning to walk. Hey, there you go. This idea comes from the main theory of how galaxies form. They grow inside halos of hypothetical dark matter, the invisible stuff that makes up 85% of all the universe's mass. You can't see it or touch it, but its gravity acts like cosmic glue, pulling galaxies together. And those tiny red galaxies could be cradled in dark matter, waiting to start spinning and growing into the big galaxies we see today. The astronomers think these baby galaxies could live in halos that spin super slowly, more slowly than 99% of halos in the universe. It's easier to picture if you imagine holding a rope and spinning around. Spin fast and the rope flies out. Spin slowly and the rope just droops to the ground. That's exactly what could have happened with these galaxies. The halos were too slow to stretch them out, so they kept the galaxies tiny. This could help explain why we only see such red dots in the universe's baby pictures. Over time, the halos would speed up, and the galaxies inside would grow and spread out, eventually looking like the galaxies we're used to. Loeb explained it like this: dark matter halos have a rotational velocity. Some spin fast, some spin slowly. If you assume that these little red dots are in the slowest 1% of halos, all the strange things we see about them suddenly make sense. But the thing is, this isn't the only explanation. Two other teams of astronomers have recently suggested that these dots could be something totally new, a type of cosmic object they call black hole stars. An international group of astronomers and physicists, including experts from Penn State, think these dots are actually giant balls of hot gas that are so dense they look like the atmospheres of normal stars. But instead of being powered by nuclear fusion like regular stars, these are fueled by supermassive black holes in their centers. The black holes gobble up matter, turning it into energy, and that energy gives off the light we see. After looking at enough red dots, scientists found one with so much atmosphere that it couldn't be explained as just a bunch of normal stars in a tiny galaxy. Instead, it's basically one enormous, very cold star. Now, cold stars don't emit as much light because their temperatures are low compared to your typical stars. Most stars in the universe are low-mass, colder stars, but they're usually hard to spot because the brighter, massive stars shamelessly steal the show. As for these black hole stars, they shine in the red and near-infrared wavelengths. It's light we can't see with our own eyes anymore. And even though the gas around supermassive black holes is usually millions of degrees hot, the red dot black hole stars could be surrounded by very cold gas, like a low-mass star's atmosphere. This could explain why they glow so faintly. So, in other words, what we thought were tiny galaxies full of stars might be single giant stars powered by black holes. Now, let's figure out how the James Webb Space Telescope helped astronomers make this discovery in the first place. It's one of the most powerful telescopes in space. It was designed to look all the way back to the birth of the universe, using infrared instruments to detect light from the oldest stars and galaxies. Basically, it's a time machine that allows scientists to see the universe as it was about 13.5 billion years ago, right near the beginning of everything. The moment the James Webb started scanning the skies, astronomers noticed tiny red dots popping up everywhere. And those objects were way too massive for what galaxy models predicted. At first, the team thought they were just mature galaxies, which get redder as their stars age. But the dots were way too bright. To explain them as galaxies, the stars would have to be packed together so tightly that it seemed physically impossible. You see, a galaxy like that would make the night sky blindingly bright. To figure out the mystery, the scientists needed spectra. That's data showing how much light the objects gave off at different wavelengths. Between January and December 2024, they spent nearly 60 hours of James Webb time collecting spectra from 4,500 distant galaxies. It's one of the biggest spectroscopic datasets ever taken with Webb, and it gave astronomers an unprecedented peek at the dawn of space. In July 2024, the team spotted an incredibly extreme object. It immediately grabbed their attention. They nicknamed it the Cliff because it became the perfect test case to figure out what those mysterious red dots really were. The object spectrum showed an enormous amount of mass, the most extreme case of its kind detected so early in the universe. The light from the Cliff had traveled nearly 12 billion years to reach Earth. But the weirdest thing was that spectral analysis showed that the light wasn't coming from a cluster of stars at all. It was coming from a supermassive black hole. This black hole was pulling in surrounding matter at an incredible rate, wrapping itself up in a ball of hydrogen gas. Black holes like this are usually found at the center of galaxies, sometimes millions or even billions of times more massive than our Sun. Their gravity is so strong that matter falling in gets converted to energy, producing enormous amounts of light. The discovery of the Cliff and similar objects shows that these black hole stars might be the baby version of the supermassive black holes we see at the centers of galaxies today. Yep, astronomers might be witnessing the universe's most powerful monsters as babies, before they grew into the huge giants we know. The James Webb has already spotted signs of big black holes in the early universe. And these black hole stars might explain how the universe grew so fast. You can think of them as turbocharged space builders, sucking in matter, getting bigger, and powering up the early cosmos. The scientists plan to study them more to see how dense their gas is and how strong they really are. As for the little red dots, they're super far away, both in space and in time. And they're so tiny that studying them is tricky. But for now, the black hole star idea is the best explanation, fitting just about all the data. Researchers are working to figure out the rest, and even if some guesses turn out to be wrong, astronomers will just follow the clues, and the next idea is bound to pop up. Guess what? The universe can get actual scars, just like when you fall off a bike. Well, here's why. Before the Big Bang, the universe was extremely hot, dense, and full of energy, and it seemed like everything was going well, until that all changed about 13.8 billion years ago. Then the universe exploded. After the blast, it expanded incredibly quickly. Our human brain can't even perceive how fast that expansion was. Sometime later, the universe started cooling down. As it did, giant, terrifying scars cutting through space-time appeared all over the place. And if we study these scars well, we can even get insight into time travel. These days, we call these scars cosmic strings. They're like stretch marks that appear when the skin expands too quickly. Or we could also compare them to cracks that form in the ice when it freezes. These strings are likely very thin, about the size of a proton, a positively charged subatomic particle. Yes, subatomic means smaller than an atom. The strings are also extremely dense and can stretch for light years. Now, imagine these cosmic scars floating through space, not interacting much with their surroundings. When two cosmic strings pass each other, they could warp space-time in such a way that it creates a time machine. If you were to travel along a certain path around these strings, you would end up returning to your starting point at an earlier time, which is traveling back in time. Now, let's admit it, this idea sounds like something from science fiction, but it's supported by cosmic string theory, and the math behind it seems to work. Unfortunately, no one has observed cosmic strings yet, so for now, it's still a theory. In 1991, one physicist proposed an idea for how cosmic strings could enable time travel. If two infinite cosmic strings passed each other in parallel, they would warp space-time, creating a time loop. This loop would allow someone to travel back in time. Even better, This idea doesn't contradict Einstein's theory of general relativity, which suggests that large objects can bend space and time. These bends in space-time could allow a shortcut through time. His now well-known concept of closed time loops also helps explain how wormholes might work. So, a wormhole is basically a theoretical tunnel connecting one place in space to another. Some people believe that by using such tunnels, we could create shortcuts for incredibly long journeys through the universe, which would allow us to visit other star systems and galaxies. So, let's say you manage to create a wormhole and even accelerate one of its ends to near the speed of light, and then you send it back to where it came from. Well, at that moment, those two ends are not synced anymore. One is in the past, while the other is in the future. And if you somehow manage to walk between them, you'd be time traveling. You could do something similar by placing one end of the wormhole near a powerful gravitational field, like a black hole, and keeping the other side near a weaker gravitational force. This way, according to the theory of relativity, time would pass more slowly nearer to the strong gravity side, and it would allow a particle or another chunk of mass to remain in the past relative to the other side of the wormhole. At the same time, if you decided to create a wormhole, you'd have to keep in mind that they are super dangerous. They might collapse all of a sudden. They're likely to be highly radioactive, or you could come into contact with toxic exotic matter inside. But let's get back to the math behind the cosmic string time machine idea. Admittedly, it is solid, but it doesn't mean such a time machine is possible yet. To use this way of time travel, we'd need to reach near light speed, and it might be impossible. According to Einstein's relativity, the faster an object travels, the more energy it needs to continue speeding up. In other words, we don't yet have the technology or energy sources to accelerate a spacecraft to these speeds. The idea of two infinite cosmic strings is also questionable because we can't create something that's infinitely long. So, while this time travel model is mathematically sound, the infinite nature of the strings would make this exact model impractical. At the same time, some scientists still believe that cosmic strings are a better possibility than most other models, like wormholes. In any case, before we can start considering time travel, we need to discover cosmic strings. Luckily, there's a group of astronomers working to detect low-frequency gravitational waves by measuring signals from a type of star called a pulsar. Now, pulsars send out regular pulses of radio waves, and by measuring small changes in the timing of these pulses, scientists can detect subtle shifts in space-time. Those changes are caused by gravitational waves, which are ripples in space-time. Now, so far, we've only detected gravitational waves coming from black holes. But in 2020, there was one strange signal that didn't look like it came from black holes. It could be coming from cosmic strings. And here, we need to mention string theory. According to Webb, the universe is made up of more than just the four dimensions of space-time. There are additional dimensions that are hidden from us. Plus, the basic building blocks of the universe aren't particles, but tiny vibrating strings. These strings can vibrate at different frequencies to create different fundamental particles. These strings, from string theory, could have stretched out during the early universe and become the very cosmic strings we've discussed. In the coming years, we might get more information about them from a space-based gravitational wave telescope called LISA. It's supposed to launch in 2035. But if the signals picked up in 2020 really came from cosmic strings, it could mean a huge breakthrough in physics. In this case, string theory would become the right framework for understanding the universe. It would completely change the way we think about the building blocks of our reality. On the other hand, even if the signals don't turn out to be from cosmic strings, this discovery would still be important. It would give scientists more information on what cosmic string signals might look like in the future. And while we're not yet at the point of time travel, the discovery of cosmic strings could take us one step closer to understanding the mysteries of the universe and maybe even the possibility of traveling through time. Now, time travel is a popular theme in science fiction, but in fact, moving forward in time happens naturally. Right now, you are traveling into the future at a steady rate of 1 second per second. However, scientists have discovered that this rate can change depending on speed and gravity. Einstein's special theory of relativity explains that time slows down as an object moves faster. The closer you get to the speed of light, the more slowly time passes for you, compared to someone who isn't moving at all. The general theory of relativity adds another factor, gravity. The stronger the gravitational pull, the more slowly time moves. Near massive objects, such as the surface of a neutron star, black hole, or even Earth, time runs more slowly than it does far away from these space objects. If someone were to stay near the edge of a black hole, where gravity is incredibly strong, only a few hours might pass for them, while thousands of years would go by for people on Earth. If they returned, they would have effectively traveled into the future. This is a real and scientifically proven effect. A real-life example of time travel, though on a tiny scale, can be witnessed in space missions. For example, this cosmonaut spent a total of 748 days aboard the space station Mir during 3 separate missions. Because Mir was moving at high speeds relative to Earth, it experienced time dilation. As a result, he aged 0.02 of a second less than had he stayed on the ground. Now, this difference may seem tiny, but it shows that time moves differently depending on speed and location. But while traveling to the future is scientifically possible, traveling to the past is much more complicated and controversial, and leads to logical paradoxes. Imagine you throw a billiard ball into a time machine. It travels to the past and collides with its earlier self. This prevents the ball from ever entering the time machine in the first place. A contradiction.
In 2020, strange signals from deep beneath Antarctica sent shockwaves through the news. Within days, headlines exploded. NASA had found a parallel universe where time runs in reverse. But what really happened? And what did scientists actually detect? Well, this story is a case of madness, misunderstood experiments, and the human need to believe in mystery. Even today, every few months, someone reposts a headline screaming that NASA found a parallel universe in Antarctica. A universe where time flows backwards, and people believe it. But no, NASA didn't find a mirror world under the South Pole, or some sort of a backwards reality where people age in reverse or speak in rewound sentences. They did find something curious, though. Here's what actually went down. Scientists were flying a strange-looking instrument over Antarctica called ANITA, short for Antarctic Impulsive Transient Antenna. ANITA is a machine that floats over Antarctica, basically a giant balloon with antennas. It listens for tiny space particles called neutrinos. Neutrinos are super small and ghost-like. They have almost no weight and go through stuff like it's not even there, even entire planets. Usually, these neutrinos come from space and rain on Earth from above. Most neutrinos, the common low-energy ones, just fly right through the Earth like it's air. They're like tiny bugs flying through a chain-link fence. There are some very high-energy neutrinos, though. They're super rare and they interact a bit more often with matter, and they can get blocked. If high-energy neutrinos hit something dense enough, like the rock and metal inside Earth, they might finally bump into a particle and get absorbed. That's more like fast tennis balls that hit the fence once in a while. Low-energy neutrinos, which are everywhere and pretty harmless, are pretty undetectable. But these high-energy guys are exactly what ANITA can detect. When they slam into ice, they send some radio waves that are easy to listen to. This faint radio signal is called the Askaryan effect. And yep, that's exactly why ANITA is flying over Antarctica. That's because the ice is pure, dry, and quiet. It's perfect for catching those rare signals. So, what did ANITA detect? It detected something rising up from below the ice, like a high-energy neutrino coming from the Earth. What? Okay, let's think logically. Maybe it started somewhere in the north, traveled all the way through the Earth, and popped out the other side. Still, that's super weird. That's not supposed to happen. Neutrinos with that much energy should have been stopped inside the planet. Like we said, get absorbed. So, scientists caught a little bit of a brain bug. That shouldn't be possible with our current physics, unless something we don't understand is going on. And when you're faced with something bizarre, you explore all options, even the wildest ones. The nightmare began. A group of researchers published a paper suggesting that this strange signal might make sense in a CPT symmetric universe. CPT stands for charge, parity, and time. These are basically three ways to flip the universe. Charge means swap all particles to their opposites. For example, swap electrons, the guys with the negative charge, with positrons, their antimatter twins with the positive charge. Parity means mirror the universe, literally like looking at it through the mirror. Left becomes right and right becomes left. And time, of course, means run time backward, like rewinding a video. Now, there's a big rule in physics called CPT symmetry. It says that if you change all three of those things at once, the laws of physics should still work the same. This is kind of insane, but if you took the entire universe and swapped matter with antimatter, mirrored it, and reversed time, it would still follow the same physics. Why is that? Well, in our universe, an electron bumps into a positron, and they annihilate into photons. Cool. Now take that, mirror everything, and what do you get? Well, photons spontaneously turn into a positron and an electron, but mirrored and reversed. It's still the same physics, even if it's backwards. The equations still check out, so nature thinks this is valid. So here came the crazy part. Some physicists thought, what if the Big Bang created two universes? One is ours, made of normal matter going forward in time. The other is a mirror twin, made of antimatter, going backward in time from our perspective. This doesn't mean that someone in the other universe feels time going backward. To them, time flows forward, just like it does for us. But from our point of view, they're moving from our future toward our past. And vice versa. To them, we're weirdos who move backwards. And if both universes are exact CPT mirror images of each other, that would mean same physics, same rules, just symmetrical. Same rules, just symmetrical. This isn't some crazy sci-fi theory, even if it sounds like it. It helps explain weird physics mysteries. For example, why there's so much matter in our universe but not much antimatter, even though they were supposed to be created in equal proportions. Or why the universe is so symmetrical and balanced in some strange ways. So, coming back to the neutrinos, some scientists suggested that maybe those upward flying particles could be coming from that CPT mirror universe, poking through into ours, like a crack between two symmetrical realities. And if you look at it like that, this is quite a wild take. It's speculative. It's not proven. It's more of a cool thought, but the media immediately blew up. They ran a piece with the headline that said we found proof of a parallel universe going backwards in time in Antarctica. And all the other big tabloids picked it up. They made it sound like NASA had actually found a parallel universe. Time travel is real. Multiverse is confirmed. Meanwhile, people who worked directly on ANITA immediately caught brain damage. They tried to jump in to say that's not what happened at all. They explained that the signals were unusual, yes, but there were plenty of normal explanations that didn't require rewriting the laws of physics. It could even be just an experimental error. Maybe an unusual particle behavior or gaps in how we model neutrino interactions. Of course, no one listens to experts about what experts discovered. And once an idea like that hits social media, it becomes nearly impossible to put back in the box. But that also doesn't mean that the multiverse definitely isn't real. Far from it. Physicists are still exploring the concept and assume that some of those potential universes, if they exist, could have different laws of physics. One idea, called the many worlds theory, comes from quantum physics. It says that every time something can happen in more than one way, like a particle moving or a decision being made, all those possibilities actually happen, but in separate universes. So there could be endless versions of reality, each slightly different, branching off from every event. Maybe in one universe, dinosaurs never went extinct. Maybe in another, you never sent that embarrassing text. Another theory is called the bubble universe theory. After the Big Bang, the universe expanded incredibly fast in a process called inflation. Some scientists think that inflation never fully stopped and is still happening in some regions. That would mean new bubble universes are constantly forming, each with its own version of physics. Our universe would just be one bubble in a giant cosmic sea of others. The third idea is about shadow matter. Dark matter is invisible, but its gravity affects the universe. Some scientists think it could be made of particles similar to the ones that make up regular matter, but they're just hidden from us. This mirror, or shadow matter, could form entire invisible galaxies and even life, all existing right alongside us. Maybe we just can't detect it in any way except through gravity for now. But in physics, all of those are just theories, mathematical possibilities. We have no direct evidence that it's real. If we ever find one, though, let's now hope it won't be the boy who cried wolf scenario.
Welcome to one of the most mysterious and unexplored places on Earth. But what's so special about that? It's just some icy peaks and the endless snowy expanse of Antarctica. Yeah, that's right, but there's still a planetary scale mystery here. No matter how hard you try, you won't see a hidden mountain range, giant, unexplored land where no human has ever set foot, and it lies under another layer of mountains. It's like a nesting doll, but the size of a continent. These mountains hide Antarctica secrets, and these secrets can tell us something awesome about the ancient history of our planet. This gigantic unexplored territory in Antarctica is called the Gambritsev Subglacial Mountains. And the layer of ice above keeps this place untouched by nature and people. It's like a land inside another land, and it hides more than just mountains. There are valleys, hills, and plains. The whole area is similar to the European Alps, but unfortunately, we can't enjoy the view. Those mountains were first discovered in 1958 using seismological instruments. More than half a century has passed since then, and this place still remains one of the most poorly studied tectonic objects on Earth. Why? Because it's ice. A lot of ice. Who knows? Maybe there are some unknown ancient artifacts lying there. What if they're hiding a secret city or spaceships? It's unlikely, of course, but it would still be interesting to look there. Think about it. Hundreds or even thousands of miles of land that have remained unchanged for hundreds of millions of years. Even if no new species of animals or remains of an ancient civilization are there, this place still has a history. The history of the formation of continents on our planet. And scientists have already figured out some of this story. The mountains buried in Antarctica were originally like ordinary mountains, but as a result of a planetary scale event, they just… Wait a minute. Have you ever wondered how mountain ranges are formed? We see them in real life, in movies, in photos on the internet. We climb them. But how did they appear? Mountains have not always existed on the planet in this form. They appeared as a result of a large-scale collision of tectonic plates. Two giant solid chunks of ground are moving toward each other, then crash, and boom! Millions of tons of the Earth's crust pile on top of each other, mix, and form ledges and gorges. And all this can last for millions of years. Yes, it's a disaster, but it's very slow. Some tectonic plates are still colliding. For example, the Himalayas continue to grow because the Indian and Eurasian plates are still ramming into each other. And this process began about 50 million years ago. The Gambritsev Mountains under ice experienced a similar event, only much earlier. An article in the journal Earth and Planetary Science Letters says that they appeared during the formation of the supercontinent Gondwana. Two giant pieces of land were separated by a boundless ocean. But then, about 700 million years ago, they collided and formed Gondwana. This supercontinent included the territories of modern Africa, South America, Australia, India, and Antarctica. The giant pieces crashed into each other and released a stream of hot, partially molten rock. This mess grew bigger and bigger, forming mountains. The temperature of those mountains grew, their mass increased, and at some point, Gondwana became unstable. The supercontinent began to collapse under its own weight. The hot rocks below the surface began to flow sideways as a result of a process called gravitational spreading. Take toothpaste and start squeezing it out of the tube. Approximately the same thing happened with billions of tons of red hot rock. Ancient mountains in Antarctica appeared right during this catastrophic event. You've just watched a visual simulation of global events that took place hundreds of millions of years ago. It looks cool, but how did scientists figure it out? How did they see this planetary scale destruction? If the Gambritsev Mountains under ice is one of the most unexplored places in the world, then how could people find out its origin? The answer is simple. Tiny particles of rock have told us about the changing landscape of the planet. These are zircons, but scientists also call them time capsules. This mineral is very handy and resistant to mechanical and chemical influences. It's difficult to crush, it doesn't get affected by erosion, and it doesn't dissolve in water. And there's uranium inside it. This chemical element shows scientists the age of the rock. The fact is that uranium always decays into lead at the same rate. Scientists look at the ratio of uranium and lead and determine the age of minerals with great accuracy. Okay, this sounds a bit complicated. Here's a simple example. Imagine that each mountain belt is a clock that starts ticking at the moment of its formation. That is, after the collision of tectonic plates. After the rock forms, uranium begins its slow decay. The more time passes, the more uranium turns into lead. The rate of this decay is always the same. This decay can last for billions of years. The less uranium is in zircons and the more lead, the older the rock is. And this is how it happens in practice. Geologists take several rock samples. In a lab, they crush it to extract crystalline zircons. Geologists then dissolve the particles in acid to separate uranium from lead. Then they use a special device, a mass spectrometer that accelerates atoms and sorts them by mass. This is a rather complicated process, but the bottom line is that this device shows scientists the amount of uranium and lead. They look at the ratios of these two elements and calculate the age of the rock. Geologists took zircons from sandstones near the Gambritsev Mountains, studied those particles, looked at the level of uranium, and calculated the chronology of mountain formation. Then they compared the data obtained with the history of our planet and realized that the mountains buried in Antarctica appeared during the formation of the supercontinent Gondwana. But how did they find out that the supercontinent included Australia, India, and Africa? Zirconia from those Antarctic rocks turned out to be very similar to zirconium from those countries. That is, a long time ago, these three continents were together. So, the Gambritsev Mountains began to grow about 650 million years ago. About 580 million years ago, they reached the height of the Himalayas, and 80 million years later, they experienced the melting of the Earth's crust. And while most of the mountain ranges on the planet were changing and collapsing, the Gambritsev Mountains under ice remained untouched. Water, soil, wind, earthquakes, gravity, and other natural forces destroy mountain belts. This process is called erosion. But mountains buried in Antarctica haven't experienced anything like this. The cold temperature and the ice sheet around them kept this range unchanged. It's one of the best preserved ancient mountain belts on the planet. Okay, but why do we need to explore these mountains? What difference does it make that the supercontinent Gondwana collapsed in the past? It's possible that plants, frozen bodies of insects, or ancient bacteria have remained preserved under thick layers of ice. What about ancient animals? Many species could have lived on Gondwana. Studying ancient mountains in Antarctica can show us what the planet looked like about 500 million years ago. When Antarctica was a green continent, what lived on it? What happened to this life? Is it possible to revive those ancient creatures after so many years? If scientists were able to calculate the date of the supercontinent's appearance using tiny particles, then imagine what they could find after examining this hidden mountain range. It all sounds very interesting, but there's one problem. To take a small piece of this unknown world, you need to drill through a lot of ice. You need to deliver heavy equipment to one of the most inaccessible continents in the world, build stations, obtain an energy source, and conduct large-scale research. It sounds incredibly expensive, so this hidden territory will probably remain a mystery for a long time. Let's just hope that some billionaire will want to find out Antarctica's secrets and arrange a large-scale expedition there. There's a huge hole on Mars, more than 300 feet wide, and it seems that NASA agrees that it could be an opening into an underground world. Could a mysterious space civilization be hiding in there? Well, experts from NASA think that the hole might lead to a lower layer under the surface of the red planet. You can think of it like a trap door that opens into a basement. Scientists care a lot about holes like this because they might connect to big underground caves. These caves would be hidden from the surface and could be safer places for life to exist. You see, Mars' surface is a rough place. It's freezing cold, extremely dry, and constantly hit by radiation. Meanwhile, underground spaces are different. They're like natural shelters, protecting anything inside. That's what makes them some of the best places to look for signs of life on Mars. Interestingly, NASA is usually very careful when talking about life on other planets. Until now, most researchers have been focusing on tiny life forms like microbes, which might be hiding in frozen oceans on nearby planets and moons. But now, scientists really think this hole could lead to huge underground caves. If that's true, besides looking for signs of life, this spot could become a target for future astronauts, since the caves could turn into great shelters and even a Martian base. The photo with the hole isn't new. It was taken in 2017 by the Mars Reconnaissance Orbiter. In the image, we can see many holes scattered across the ground. The area basically looks like Swiss cheese. Most of the holes have dark, dusty ground under a thin layer of light-colored frozen carbon dioxide, aka dry ice. But one hole stands out from the rest. It's perfectly round, sits in the upper part of the image, and is about 328 feet wide. That's a massive opening. The hole also has a perfectly round crater around it. It's like something punched through the surface and left a ring behind. Scientists think it may have been caused by a meteor impact. Scientists believe Mars was much more like Earth billions of years ago, with better conditions for life. But today, the best chance of finding signs of life is underground. Mars no longer has a strong magnetic field or a thick atmosphere, so its surface is constantly blasted by harmful radiation from space. Underground caves or lava tubes act like natural bunkers, shielding anything inside from that radiation. This makes them the most promising places to search for life. Because of that protection, astronauts might one day find signs of past life there, or even fossils. To hunt for these hidden spaces, NASA brought in experts on underground structures and seismic activity from the U.S. Geological Survey. In 2019, they released a detailed map showing more than 1,000 possible cave entrances scattered all over Mars. There's a catch though. All of this data comes from spacecraft flying about 250 miles above the Martian surface. From that height, scientists can spot holes, but they can't see how deep they go or what's underneath. Some may be true caves, while others could just be shallow dents in the rock. Other missions, including the European Space Agency's Mars Express, have also found signs of ancient lava tubes beneath Mars's long-extinct volcanoes. But what makes this newly released image stand out is that it clearly shows at least one hole that appears to lead into an unknown underground layer. And if current plans come true, the earliest human astronauts could see this massive opening with their own eyes in the 2030s. And maybe they'll also be able to examine another Martian mystery. For more than 50 years, scientists have been puzzled by about 2 million dark streaks spread across the surface of Mars. These black marks look like long stains or shadows running downhill. It's almost like someone spilled ink on the planet. They were first spotted in the 1970s, and for decades, no one could explain what caused them. These marks are called slope streaks. They appear on steep slopes, crater walls, and ridges all over Mars. From far away, they look flat and dark. At first, scientists thought the streaks were caused by melting ice. This could create muddy landslides similar to wet dirt sliding down a hill on Earth. Even today, researchers still believe the streaks come from landslides, but not the kind involving water. New research using data from NASA's Mars Reconnaissance Orbiter shows that most of these streaks are caused by dry landslides. Instead of mud or water, it's loose dust suddenly slipping downhill, more like dry sand pouring off a pile when it gets disturbed. This explains how the streaks can form in Mars's cold, dry environment. One famous example is on Apollinaris Mons. It's an extinct volcano south of Mars's equator. On one side of a ridge, hundreds of streaks run side by side, which makes the surface look like a barcode. These streaks appeared sometime between 2013 and 2017. Scientists figured out a bit later that a nearby meteoroid impact could have triggered them. The impact didn't hit the ridge directly, but the shock shook the ground, and it was enough to send dust downhill. Now, because some streaks appeared after impacts, many scientists thought that meteoroids or Marsquakes were responsible for creating most slope streaks. But a new study shows that this idea is kinda wrong. The study in question looked at about 2.1 million slope streaks. They were photographed by NASA's Mars Reconnaissance Orbiter over a long period, from 2006 to 2024. Scientists have estimated that Mars has around 1.6 million slope streaks in total. But some streaks have been counted more than once because they appear in different image sets. So, after analyzing all this data, researchers have concluded that almost all new streaks form because of wind and dust, not impacts or quakes. Look, seasons change on Mars and winds slowly move dust and sand. When that loose material suddenly slips downhill, it leaves behind a dark streak. It's like brushing dust off a surface and revealing a darker layer underneath. Meteoroid impacts and Marsquakes do create some streaks too, but only in very specific spots. Overall, they play a very small role. Less than 0.1% of new slope streaks are caused by impacts and Marsquakes. The analysis has also shown that slope streaks are not spread evenly across Mars. They're grouped into 5 main regions. In each of these areas, new streaks usually form during times of the year when winds are strongest. There's a key tipping point called the dust movement threshold. Once winds get strong enough to lift and move dust, the loose material on slopes becomes unstable. When that happens, dust can suddenly slide downhill, creating a dark streak. This is similar to how strong winds on Mars can kick up dust and form spinning columns called dust devils. They're like small tornadoes moving across the planet's flat plains. One reason this mystery took so long to solve is that these streaks form when scientists can't easily see them happen. The conditions that create new streaks usually occur around sunrise and sunset. And because this phenomenon happens in low light, no spacecraft has directly watched a streak form in real time. The study also calculated how often new streaks appear. On average, about 0.5 new streaks form each year for every existing streak. And since Mars has around 1.6 million slope streaks, that's roughly 80,000 new streaks forming every year. Most streaks seem to stick around for several decades before they slowly fade away. However, scientists don't yet have enough long-term data to be completely sure. Another cool discovery: even though slope streaks cover less than 0.1% of Mars' surface, they may be one of the biggest sources of dust in the Martian atmosphere. In other words, these small-looking features may play a much larger role than we expected. That's why understanding how slope streaks move dust around Mars is important. Mars's dust affects weather, visibility, and even how much sunlight reaches the ground. That matters a lot for future human colonies, which would need stable conditions to survive and operate safely. It started as a routine cleaning to scoop some mud off the coast of Indonesia, but turned into a discovery of remnants of a lost, submerged, Ice Age landmass. Archaeologists found more than 6,000 fossil fragments, and among them, 140,000-year-old Homo erectus remains. This find made scientists rethink how early humans lived, moved, and interacted in Southeast Asia. For years, they thought that Homo erectus on Java Island lived in isolation, separated from the rest of the world. But these dredged fossils blew that story apart. It turns out Java wasn't an island at all back then, but part of a landmass called Sundaland. So, Southeast Asia stretched out like someone had drained the ocean, connecting Indonesia, Malaysia, Borneo, Thailand, and Vietnam into one gigantic landscape. Today's islands of Java, Sumatra, Borneo, and Bali were connected by river systems that probably looked like the Amazon, by forests where giant animals roamed, and by coastal plains that would later sink beneath the ocean when temperatures went up. And Homo erectus were not stuck. They were thriving in what honestly sounds like prehistoric bliss. Yep, it was nothing like we normally imagine Ice Age, a sort of frozen wasteland. Sea levels dropped more than 400 feet because so much water froze into glaciers. When all that water got locked up in ice, whole sections of the ocean floor popped out of the water like stepping stones. Suddenly, early humans didn't need boats. They could literally walk from what's now mainland Southeast Asia all the way to places that are islands today. They could do it while exploring and chasing herds across open land. It was sort of like a giant prehistoric highway system. That giant highway matters because it completely rewrites how early humans moved around. Instead of being trapped, Homo erectus had a whole continent to roam. They followed rivers, crossed valleys, and adapted to different environments the same way you learn shortcuts to the office or find new routes to your favorite coffee shop. And because everything was connected, animals wandered freely too. Tigers, elephants, supersized cows, and turtles the size of small cars. People followed these big animals. This among the fossils pulled from the Madura Strait, such as cut-marked turtle shells and cracked open bovid bones. When you see precise cut marks on bone, it means someone was deliberately carving meat off the bone with tools they made themselves. And cracked bones mean they were taking out marrow, which was like prehistoric energy gel, rich, fatty, and perfect when you need calories to survive. That's a level of planning and skill scientists didn't expect from Homo erectus. It pushes Homo erectus closer to species like early Homo sapiens and Denisovans when it comes to behavior. It means they weren't just surviving on scraps, they were actively pursuing animals, processing, and maybe even sharing food the same way later humans did. So if you imagine them as slow, hunched cavemen, forget that. These people were sharp. The techniques they used to process food look eerily similar to those used by other hominins. Not just Homo erectus, we're talking Homo floresiensis, Denisovans, and early Homo sapiens. That opens the door to the possibility that these groups didn't just exist side by side. They might have interacted. Maybe they traded ideas and copied techniques. Or maybe they even interbred or shared territories. All this makes Southeast Asia look not like a series of isolated islands, but like a buzzing human ecosystem, a place where different human species crossed paths. And here's the heartbreaking part. Everything we know about this place, everything humans built, lost, and discovered there, is all underwater now. When the Ice Age ended, glaciers melted like forgotten ice cream cones on a hot sidewalk. Sea levels rose. Slowly, then quickly. Rivers flooded, coastlines vanished, entire human landscapes disappeared beneath the waves. Sundaland drowned over thousands of years, and the people who lived there either adapted or moved to higher ground. Archaeologists now try to interpret what these people did, how they lived, and how many human species walked that land. Every time they pull together bone or artifact from the seabed, we get one step closer to rewriting everything we thought we knew about early human migration. And the new discovery could mean that Southeast Asia may have been just as important to human evolution as Africa, the Middle East, or Europe. Looks like Sundaland wasn't a side quest, but a real mixing zone, a place where humanity experimented, adapted, learned, and evolved. Unexpected finds like this one in Indonesia keep popping up around the world and surprising scientists. Farmers in China were hoping to scoop up bat droppings for natural fertilizers inside a narrow limestone cave. But instead, they spotted pieces of fossilized bone that looked suspiciously like parts of a human skull. This skull turned out to be ridiculously old, around 300,000 years old. Scientists eventually named the fossil Maba 1. The discovery happened way back in 1958, but ever since then, nobody could agree on which ancient human species this skull belonged to. During the late Middle Pleistocene, the world was basically a crowded highway of different ancient human species wandering around. Or just maybe, Maba 1 came from a species we've never met before. The big issue was that researchers only found part of the skull, no jaw, no other bones. So it was like trying to solve a giant puzzle with half the pieces missing. For ages, scientists guessed it might be Neanderthal. But now they've used micro-CT scanning, which is like an X-ray superpower that lets you peek inside fossils without breaking them. That's when they noticed weird tube-like structures connecting parts of the brain case, something Neanderthals basically never had. The inside shape of the skull looked way more like Homo erectus, a much older human species, but even that wasn't a perfect match. The skull's size and shape were closer to modern humans and Neanderthals, and it showed traits Homo erectus usually didn't have. For example, it had a shorter forehead area and a thickened bregma, the meeting point between two skull bones. Maba 1 also had a strange dent on the forehead, almost like a bruise frozen in time. Whatever caused it, maybe a fall, maybe anemia, it happened while the person was alive, but there was no sign of infection, so that individual probably healed and kept living after whatever hit them. So Maba 1 doesn't match any known species perfectly, but it shares features with several and has a similar mystery fossil vibe as others found across Africa. In 1976, a famous paleontologist and her team found another human-like skull in Tanzania. That skull had features that looked surprisingly similar to Homo sapiens, even though it was unbelievably old. Scientists think it may be one of the earliest examples of our species ever discovered. That means this skull could help solve one of science's biggest questions. When exactly did Homo sapiens first show up? The sediment layer where that skull was found goes all the way back to the Middle Pleistocene. That's way earlier than what old textbooks used to claim about when modern humans appeared. And then there's a skull that turned up in Zambia's Broken Hill ore mine. Miners literally stumbled on it, plus a few other bones, completely by accident. Scientists started calling it Rhodesian Man, and at first, everyone thought it might be the big missing link between Homo erectus and Homo sapiens. But with newer research tools and better dating methods, they discovered it's around 299,000 years old and probably belonged to someone from the species Homo heidelbergensis. Every new fossil acts like a missing puzzle piece on the giant chaotic story of human evolution. Each one helps scientists connect species that once seemed unrelated, redraw family trees, and rewrite chapters of our past we didn't even know were wrong. Clouds of blazing ash obscure the sun. The ground is shaking. People are running in different directions. A volcanic eruption has begun. And it started suddenly. A small, sunny coastal town is facing one of the most devastating natural disasters. The ash will settle. Lava will spill out of the volcano's mouth. And within a few hours, the ancient city of Pompeii will be in... Wait a minute. People get into cars and drive away. This is not Pompeii. This is a modern town. Huh? Is it possible for a city to get buried during an eruption today? Unfortunately, yes. Welcome to Montserrat, which is also called the Pompeii of the Caribbean. Montserrat is not a city. This is the British Overseas Territory in the Lesser Antilles, one of the Caribbean islands. It has the Soufriere Hills volcano that turned the lives of many residents of the capital, Plymouth, into a nightmare in 1995. But what kind of place is this, and why do people live here at all? The Montserrat area is not very big. It's about 6 times smaller than the Chicago area, and there aren't many people living here. Before 1995, the population of Montserrat was about 15,000 inhabitants. It's not a lot, but the island gathered several different cultures, as it was inhabited by the Irish, Africans, and indigenous people. Montserrat is one of the youngest volcanic islands of the Lesser Antilles. Before 1995, the Soufriere Hills volcano erupted here in the 17th century. Many years had passed since then, so people were not very worried about its new awakening. They rested, worked, had fun, went boating to other islands, and all this continued for about 300 years. Then, the serene paradise life ended. In 1995, seismic activity began. It continued for several months and led to an explosive eruption in 1996. Fortunately, no one got hurt, but the real disaster hit in June 1997. Something bad started happening at the top of the Soufriere Hills. At an altitude of about 3,000 feet, the volcano began spitting out ash clouds, rocks, and hot gas, releasing its boiling innards, which were rapidly falling down the steep slope. The locals were terrified. Some people had evacuated from the island by that time. They had to leave their homes and sail away, but some locals stayed and didn't survive. The pyroclastic flow destroyed many buildings, streets, and roads. In case you didn't know, the pyroclastic flow is a dense, thick mix of volcanic ash, lava, and hot gases that moves as an incandescent mass at high speed. It burns and destroys everything in its path. On that day, the pyroclastic flow was moving at 62 miles per hour, with its temperature reaching around 1470 degrees Fahrenheit. Imagine boiling water. Pretty hot, isn't it? And the temperature of that pyroclastic flow was almost 7 times higher. One part of the inhabitants of the island moved to its northern part, and the other migrated to the neighboring islands. Since then, Plymouth has become a ghost town. Thanks to the solidified magma, you can see buildings that seem to have particularly sunk through the ground or are stuck in textures. The streets are deserted, and the roads are covered with a thick layer of volcanic mass. After the eruption, only 1,000 people stayed on the island. There are about 4,500 people living there now, all of them in the northern, safe part. The southern side of the island is now called the exclusion zone. It's divided into 5 parts: A, B, C, F, and V, the most dangerous area. Why is it dangerous? Because the volcano is still active. Periodically, it spits out clouds of ash. It can erupt with devastating force at any moment, but that doesn't stop thrill seekers. Montserrat attracts many tourists who like to walk in the picturesque areas near the active volcano. People also love the ghost town. The roofs of houses, spires, and the remains of the clock tower stick out of the solidified lava. Broken windows with torn curtains and dilapidated former hotels attract many tourists. You can enjoy the beautiful tropical northern part of the island and see the apocalyptic picture in its southern part. Locals actively promote tourism and advertise their home as the Pompeii of the Caribbean. Would you like to visit this place? Living next to a volcano is quite risky, but how about living inside a volcano? Near 220 miles south of Tokyo, there's a beautiful island of Aogashima, most of which is occupied by an active volcano. But how can people live inside a volcano and not be afraid? The answer is simple. This place is too beautiful. Besides, the last major eruption occurred there at the end of the 18th century. People don't live right inside the crater, that would be too much. A small settlement is located inside the outer wall of the crater, far from the geothermal activity and quite far from the dangerous peak. But it's still a pretty extreme place to call home. The population of the island is about 170 people, and they're not going to leave. Here you can find only one shop, one post office, free camping, and a couple of guest houses and 3 bars. It sounds pretty cozy considering that all this is located in a green paradise. But in 1785, this paradise resembled Pompeii during the infamous catastrophe. According to stories and remaining records, the first tremors occurred on May 18 or so. It was a warning of the impending disaster. At that time, 327 residents lived in Aogashima. It's not known whether they attached importance to the small earthquake, but they continued to live peacefully for another couple of weeks. The volcano's activity increased. The disaster was inevitable, so evacuation from the island began on June 4. Unfortunately, it was too late. There were earthquakes, terrible roars, and streams of hot lava that covered trees, roads, and houses. Many didn't survive that day. And still, the descendants of those who escaped from the island that day now reside in Aogashima. Aren't they afraid of another eruption? They look at this situation differently. Nothing can stop nature, so there's no point in resisting. And if there's no eruption, then it's better to enjoy the picturesque views and the relaxed rhythm of the island. Few people live there, and there's almost no urban entertainment, but still, you can find what to do. In the afternoon, you can walk along the Green Mountain Range and enjoy the view of the Philippine Sea. You will feel one with nature, beautiful birds, the warm sun, and the physical exertion of the trip. It will all charge you with energy and inspiration. You can also go fishing, camping, or chat with the locals. At night, you can look at the stars. The night sky is perfect in Aogashima. Away from city lights, there's a low level of light pollution. A detailed star map can help you study celestial bodies without a telescope. Since the place is essentially an active volcano, you can find many geothermal springs there. One of the coolest and most popular places to visit is Aogashima Furiai. It's a sauna that uses volcanic energy to maintain high temperatures in the steam rooms. And outside the rooms, you can also find hot air vents for cooking. How about an omelet fried in volcanic heat? Sounds appealing. Of course, it's quite difficult to get to this place since Aogashima is a very remote island. You first need to get to the nearest larger island, Hachichojima. There are regular flights to it directly from Tokyo. You can also choose a more romantic trip and take an overnight ferry. It's only 2.5 hours by boat between Hachichojima and Aogashima. But if you've spent enough money, you can pay for a helicopter trip and spend a mere 20 minutes to get there. It wouldn't be surprising if you wanted to stay on the island forever after visiting it for the first time. A measured life in nature or the bustle of the concrete jungle? Which one would you choose? But don't forget that at any moment you can feel the ground tremble. But let's hope there won't be any eruptions soon. Look at this giant donut-shaped region far away from Earth, beyond the orbit of Neptune. We're talking about a distance of more than 2.5 billion miles. It's the Kuiper Belt, and something eerie and bizarre is happening there. Dwarf planets and other small objects dwelling there refuse to cluster together. Instead, they follow particular orbits, which is weird. The reason might be a large, mysterious planet hiding beyond Pluto. Its gravity might be messing up the orbits of those Kuiper space bodies. Hear me out. Our solar system is made up of the Sun and everything that goes around it because of the star's strong gravity. This includes the 8 main planets: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. There are also smaller things like moons, asteroids, and Pluto. For a long time, people thought Pluto was the 9th planet, but when it was reclassified as a dwarf planet, scientists started looking for a new Planet X. Did they have a thing about odd numbers or what? And guess what? Some really think there might be a big, icy planet hiding far, far away beyond Neptune. This mystery planet is often called Planet 9. Now, Planet 9 hasn't been seen yet, but scientists think it might be out there because of some tiny, faraway space rocks called etnos that move following bizarre, confusing paths. These paths seem to be grouped together and tilted in a way that doesn't happen by chance. This could mean there's a hidden planet pulling them into place with its gravity. If Planet 9 is real, it might be 5 to 10 times heavier than Earth. It would also be super far away, hundreds of times farther from the Sun than Earth is. Over the years, scientists have guessed different distances for its orbit, and the newest guess in 2025 says it could be about 290 times farther from the Sun than Earth. There are some cool ideas about where Planet 9 came from. It might have started as a big planet that Jupiter once kicked out of the inner solar system, or it might have come from another star or even wandered around space on its own before getting caught by the Sun's gravity. Even though scientists have looked really hard using powerful telescopes, no one has actually seen Planet 9 yet, and so far, its existence is still just a theory. But recently, a group of researchers tried something clever. They used data from two special space surveys called ERAS and ACARI. These two looked at the sky in invisible light, far infrared, about 23 years apart, which is helpful because Planet 9 is supposed to move very slowly. The team focused on a special list from ACARI, which is better at finding faint, moving things in space. They guessed how bright Planet 9 might be and how fast it might move based on how big, far away, and cold it could be. Then they looked for matching blips in the sky that were seen by both ERAS and ACARI, but not in the exact same spot. That's because a real planet would have moved a little over 23 years, and they indeed found 13 possible matches that could be Planet 9. Their estimations were based on how far away the object seemed to be, 500 to 700 times farther from the Sun than Earth, and how heavy it might be, which is 7 to 17 times Earth's mass. After looking very carefully at all the images, they narrowed it down to one really good candidate. The two detections weren't in the same spot in both surveys, and the way they appeared in the ACARI map matched what you'd expect from a slow-moving object. It showed up on one date and wasn't there 6 months earlier, but of course, there was a catch. Apparently, the old data isn't good enough to figure out the exact path of the potential planet. So, the team wants to do new follow-up observations using a special camera called DCAM, which is really good at spotting faint, moving objects. That way, they can find out if this candidate is really Planet 9. Additionally, it can help us learn more about how our solar system works and how it formed. If Planet 9 is ever discovered, it would totally change the way we understand our solar system. It could explain why some far-out space rocks in the Kuiper Belt tilt weirdly. The thing is, most planets go around the Sun in a flat-ish circle, but those faraway objects are tilted about 20 degrees. Planet 9 might be the reason why. Next, we'd probably find out why those tilted objects seem to point the same way. Their orbits are grouped together in one direction. A big hidden planet's gravity could be hurting them like sheep. There are also some strange tilted objects super far away. They don't make sense unless something big, like Planet 9, is tugging on them. A few space rocks orbit the Sun backward between the big planets, which is kinda the wrong way. That's super weird unless something big is messing with them. Some far-out Kuiper Belt objects keep crossing Neptune's path and haven't been flung away. That's because Planet 9 might be helping keep their orbits stable over a long time. Another cool thing is that if Planet 9 existed, it would be a super-Earth, a kind of planet we see a lot around other stars, but we don't have in our solar system yet. So finding one here would make our solar system more like the others out there. Throughout history, people have been wondering if there could be hidden planets far beyond Neptune, even before Pluto was found. Back in 1880, a guy named George Forbes guessed there might be 2 unknown planets way out there, one about 100 times farther from the Sun than Earth, and the other about 300 times farther. He thought these mystery planets might be pulling on some comets and changing their orbits, kind of like how Jupiter does with the comets near it. In 2004, scientists found a weird little world called Sedna. It had a strange path around the Sun that didn't seem to be affected by any of the known planets. Its closest point to the Sun, called perihelion, is way too far for Neptune to be the reason. This made some scientists wonder if Sedna got pushed into its path by a hidden planet, maybe even something as big as Earth or bigger. Others thought maybe it was a star that flew by a long time ago, or another star that formed near ours. Then, in 2014, another odd object was discovered. It had a very similar orbit to Sedna, which made people even more suspicious that there could be something big out there messing with their paths. This kicked off a new round of the Planet X or Planet 9 hunt. At a meeting in 2012, a scientist named Rodney Gomez said that maybe there was a big, hidden planet around 1,500 times farther from the Sun than Earth. He thought it could explain the orbits of other odd objects, like some far-out comets and centaurs, small bodies that wander among the giant planets. At that time, those who supported the Planet 9 theory believed that if it existed, it would move around the Sun in a huge, stretched-out circle called an elliptical orbit. It would be about 400 to 800 times farther from the Sun than Earth is, about 13 to 26 times farther than Neptune. If it really had that kind of orbit, it would take around 10,000 to 20,000 years to go around the Sun just once. Plus, if it indeed orbited the Sun, it wouldn't follow the same flat path as the other planets. Its path would be tilted by about 15 degrees to 25 degrees. The farthest point in its orbit, called aphelion, would be in the direction of the Taurus constellation. As for the closest point, it would point towards Serpens, Ophiuchus, or Libra. As for the composition of Planet 9, it would probably be a lot like Uranus or Neptune. It would have a thick atmosphere made of hydrogen and helium, and it would be super cold, negative 375 degrees Fahrenheit. Its core would be made of iron, and its middle layer would be full of rock and water ice. At the same time, if the planet was smaller and denser, then it might be more like Earth, with a rocky surface instead of a gassy one. According to a scientist named Mike Brown, if Planet 9 was real, a space probe would reach it in about 20 years if we used a powerful slingshot path around the Sun. Over the years, archaeologists have uncovered all kinds of stuff on runestones, curses, poems, protective magic spells, and even inheritance disputes. However, a newly uncovered ancient Norse artifact known as Svingerud Stone has just one word on it. Sounds boring, right? Well, think again, because this might just be the oldest runestone ever discovered, almost 2,000 years old. But that's not all. Excavations are still ongoing, and depending on what follows next, it could unravel secrets and the true meaning behind the mysterious magical runes. So let's explore and see just how much known history you can rewrite with only one engraved word on a stone. A long time ago, during the first few centuries of the Common Era, Scandinavians and Romans crossed paths. They traded goodies like glass and silver, and eventually, Roman customs and even written culture ended up north. The Nords liked the Roman alphabet but wanted their own letters copyrighted, so they decided to create their own unique characters, which they called runes. Almost 20 centuries later, in 2021, archaeologists were excavating an Iron Age burial site near the village of Svingerud in eastern Norway. Among the cremation graves, they uncovered a reddish sandstone slab that would become a centerpiece in a major Norwegian archaeological discovery. It's the size of a coffee table, measuring just over 12 inches across. The stone was found buried with burned bones and charcoal, part of an early cremation grave. The stone had runes engraved into it, looking rough and shallow, like they were scratched with the tip of a knife or something needle-like. Runestones are not unusual. Archaeologists are used to uncovering runic inscriptions, especially in this region. However, tests show that both the burial site and the carving on the stone likely date back to somewhere between the 1st and 3rd centuries. That places it deep in pre-Viking history, centuries before the Viking Age officially began around 800 CE. That makes it one of the oldest reliably dated examples of early writing in Scandinavia. When you look at these carvings, they either look like magical symbols made to call on Nordic deities to help you, or like random scratches made by an angry man hitting a stone with something sharp. But these are real letters, crude but intentional. It's an ancient writing system used by Germanic tribes across Northern Europe. They were engraved into wood, bone, or stone. Their shapes are straight, angular lines because curves were tough to carve with the tools they had back then. When they met with the Roman Empire, rather than just borrowing Latin letters, the Germanic tribes took the idea of writing and carved out their own version. The original alphabet was called Elder Futhark. It had 24 letters. We can find them on artifacts dating from around the 2nd to the 8th century CE. Its name comes from its first 6 letters: F, U, Th, A, R, and K. Each rune probably had a name that matched the sound it made. For example, the rune that sounds like A was called Anzus. However, nobody from back then left us a memo explaining the names. In fact, the knowledge of how to read them was forgotten until 1865, when Norwegian linguist Sophus Bugge deciphered them by comparing clues. He examined later rune alphabets and ancient poems that referenced the runes, like a detective sketching a suspect from scattered witness clues. For many runes, especially the oldest ones in the Elder Futhark, the meaning is still open to interpretation. They weren't common knowledge, which is reflected by the fact that only some 350 surviving inscriptions remain. This changed eventually when the Scandinavian language evolved from Proto-Norse into Old Norse, spoken by mighty Vikings. The Elder Futhark was reduced from 24 to 16 runes to reflect the changes in the language, thus becoming the Younger Futhark, which was far better spread. Runes weren't really used to write books or keep daily records. Instead, you'd find them carved on gravestones, weapons, and various tools. It's believed that people used runes to show ownership, honor loved ones who had passed away, leave short messages, or sometimes for protection or magic. In the early days, some runes probably had special spiritual or ritual meanings too. One interesting fact about runestones specifically is that they were often used for self-promotion or boasting, like an ancient social media status or a tweet posted on a wall, or better said, a stone. One such example of a runestone from the 11th century where a man named Vigmund had it carved for himself, calling himself the cleverest of men. He even added that he was a ship captain, and yes, he made sure everyone knew that while he was alive. In the Old Norse poem Havamal, Odin says he hung on the world tree for 9 nights, pierced by a spear, to gain knowledge of the runes. This goes to show just how powerful and mystical those symbols were perceived to be. It's fitting that the word rune comes from a Proto-Germanic word which can be translated as secret or whisper. There's a common saying about power being in words, and for the old Germanic tribes, that power felt like actual magic. It's also why it's important to know when this magic came to be. And the Svingerud runestone tells us that. But it's not just when it was written, it's also what's written on it, where, and why. The location where the Svingerud stone was discovered is already a significant archaeological site. It's famous for its incredible discoveries, including the remarkable Jormungbu helmet, the only Viking helmet ever found in Norway. The stone was placed in a cremation pit, alongside the remains of an adult and a few personal items. Thanks to charcoal and bone samples, researchers can figure out how old the runestone is by using a method called radiocarbon dating. The Svingerud stone isn't the first ancient Norse artifact with runes that archaeologists have discovered, not even close. People carved runes into all sorts of everyday objects like combs, jewelry, and knives long ago. Some of those might even be just as old. Other finds have runes, but they're often broken, loose, or don't have clear dating. However, with radiocarbon dating, scientists have confirmed that the Svingerud stone is really the oldest runestone ever found. The writing on it suggests that it was part of a ritual and might have even been a message to the deceased. The inscription isn't long. It's just one word: Idiburg. No one knows exactly what it means. The clearest part says Idibera, and most researchers agree it's probably a name. Maybe Idibera in a genitive form, meaning of Idibera or belonging to Idibera. So this could be the name of the person buried there or someone being honored. There's a decent chance it's a female name, possibly making this the earliest known female rune inscriber in history. But researchers now believe that the Svingerud runestone is a part of a bigger monument. They found more than a dozen sandstone pieces scattered across several graves at the site, and when they assembled them in the lab, they fit together like a puzzle. This suggests they all came from one single upright stone. The main piece with the inscription was found in one grave, but other similar pieces were buried in nearby cremation pits. Archaeologists think it was broken and reused in a ritual, maybe to connect different people or generations who had been buried there. Instead of just marking one grave, it might have first been a memorial and was later put back into the other graves as a symbolic act. Some even speculate that the runes might have been carved by different hands throughout various time periods. The Svingerud stone might be small, but as the oldest runestone ever found with a secure archaeological context, it could be the key to how writing first took root in Northern Europe. This Norwegian archaeological discovery proves that runes were already tied to ritual, memory, and maybe even women. And if it's just a fragment of a larger monument, we've only seen part of the picture. Ancient Norse artifacts like this reshape what we know about pre-Viking history. And with luck, more runestones will follow, maybe even from another female rune inscriber.
Well, it's official. There is life on Mars. No, it's not a clickbait. Let me break it down for you. Most people imagine extraterrestrial life as little green and preferably intelligent people. But we need to distinguish between life and intelligence. When someone tells you there's life on another planet, you probably immediately think about some smart being you can converse with. But life is something different. It's often associated with organic. And NASA's Curiosity rover has found the biggest organic molecules ever seen on the red planet. They were hiding in super old Martian rocks, and I mean about 3.7 billion years old. These kinds of molecules can be leftovers from stuff like fatty acids, which help build cell membranes. It may not be the life we're used to thinking of, but at the very least, the ingredients for what we call life have been there. So, NASA's Curiosity rover has been cruising around a huge crater on Mars called Gale Crater. Scientists think this crater used to be a lake several billion years ago. The rover's main job is to find out if Mars ever had the right conditions for life. And one day, Curiosity drilled into a chunk of ancient mudstone in a spot called Cumberland. It collected some rock powder, and scientists ran a special test on it using a tricked-out oven built into the rover. That oven gets really hot, about 1500 degrees Fahrenheit. Luckily, the experiment's conditions allowed the researchers to cook off molecular oxygen, which limited the risk of combustion. And they found something surprising: chains of carbon atoms, up to 12 atoms long. You can find similar chains on Earth in everything from crude oil to, here we come again, living things. You may say that so far, The discovery doesn't sound too earth-shattering. But wait! Yep, these molecules can form naturally through non-living processes, like reactions with water, heat, and minerals. Hydrogen, carbon monoxide, heat, minerals – well, that's enough to cook up these molecules, even without biology. At the same time, such molecules are also common byproducts of life. Here on Earth, we produce similar compounds all the time, especially as carboxylic acids, which are everywhere in living organisms. So, even though these chains might have formed naturally, they could also be leftovers from something once alive, maybe microbial life, maybe something way more complex. We just don't know yet. But the most unusual and intriguing thing about the molecules is that these carbon chains are pretty fragile. On Earth, sunlight, air, and water would break them down over time. Yet, they're still on Mars after billions of years. So, even if these molecules don't belong to Martian dinosaurs, we now know that the red planet is good at preserving organic stuff. And this is huge for the search for ancient life. There's a good chance that chemical traces of that life might still be hiding in the rocks, and apparently, Curiosity is capable of detecting them. Now, by the way, this is not the first time Curiosity has found organics. It's also picked up chlorinated organics, sulfur-containing stuff, and nitrates, basically ingredients that, if life ever brewed on Mars, would have been part of the recipe. Now, how about we talk about another hero sent to Mars to make incredible discoveries? Meet Perseverance. It's a car-sized robot NASA once sent far away from home to the inhospitable and dry red planet. In particular, to an ancient crater called Jezero. The Jet Propulsion Lab created Perseverance and prepared it for its first space journey, which started on July 30, 2020. For 7 dark, lonely months, the robot was traveling through the cosmos. Luckily, it managed to land on Mars safely on February 18, 2021. NASA even gave its landing spot a cool name, Octavia E. Butler Landing, after the famous science fiction writer. Since then, Perseverance has been busy exploring the red planet. As of April 8, 2025, it's been active for 1,469 Martian days, which are, by the way, called sols. That's about 1,510 Earth days, or a little over 4 years. The rover looks a lot like its older sibling, Curiosity, but it boasts some upgrades. It's literally loaded with tech: 7 scientific instruments, 19 cameras, and even 2 microphones to record sounds from Mars, like the wind or the crunch of the rover's wheels over rocks. Perseverance also brought along a tiny flying buddy. It's a mini helicopter named Ingenuity. Ingenuity made history by performing the first powered flight on another planet on April 19, 2021. It was only meant to fly a few times, but it kept going and made 72 flights in total. Unfortunately, on January 18, 2024, it got damaged during a rough landing, so NASA officially retired it. As for Perseverance, it has big goals. It's searching for signs that Mars once had life, especially in areas that used to have water. In its search, the rover is trying to figure out if the red planet even had the environments that could have supported life. It's also searching for past microbial life, collecting rock and soil samples to bring back to Earth one day, and testing out cool tech, like making oxygen from the Martian air to help prepare for future human missions. After landing in Jezero Crater in 2021, Perseverance got to work right away, starting with its first campaign called Crater Floor. It drove south from its landing site and explored a spot called Saita. Then it returned to Crater Floor, Fractured Rough, and collected its first rock sample there. This was just the beginning of its exploration of Mars history. In its second campaign, Fan Front, the rover made its way toward an ancient delta where a river used to flow into the crater. Perseverance climbed up a valley to check out higher ground, looking for more clues about the past of the red planet. The third and fourth campaigns, Upper Fan and Margin Unit, had the rover studying rocks that could tell us more about the planet's climate and whether it could have supported life. In December 2024, they started planning Perseverance's fifth campaign, Northern Rim. It's supposed to study the crater's rim, where rocks from deep below the surface were blasted to the top during an impact billions of years ago. Perseverance has made some awesome discoveries so far. It found volcanic rocks on the crater floor that showed they interacted with water. This was a surprise, because scientists thought the rocks would mostly be sedimentary, not volcanic. At a place called Wildcat Ridge, the rover even found signs of an ancient lake that could have supported life. The rocks Perseverance has found are great at preserving potential signs of past life, so this is a really big find. The rover has also discovered some of the sediments in the delta were deposited by calm waters, but later massive floods brought large boulders into the crater. It means that Mars's climate must have been changing over time. Now, on top of that, Perseverance has done a few cool experiments. The MOXIE experiment managed to produce about 4 ounces of oxygen from the Martian atmosphere. It could be really helpful for future human missions. The rover also used its microphones to study sounds on Mars. It turned out that sound traveled more slowly there than on Earth. Plus, it was quieter on the red planet. The rover's Pixel tool analyzed rocks and found a bunch of minerals like ovoline, clays, and carbonates. This discovery showed that water had always played a big part in shaping Mars. The RIMFAX radar also helped the team see that the crater floor was made up of solid rock and volcanic material, and that the delta had formed in a calm lake-like environment. All in all, Perseverance has been giving us a much clearer picture of Mars's past. It's discovering evidence of volcanic activity, water, and environments that could have been suitable for life. It's also helping scientists gather crucial data for future missions. By studying the planet's geology, atmosphere, and potential for life, Perseverance is setting the stage for future exploration, and one day, maybe even for humans to walk on Mars. Hey, quick question. How many continents are there? 7? Maybe 5? There's no correct answer. According to different approaches, the range is between 4 to 7. But it might actually be as many as 8. Chances are, a lost continent has recently been found between Greenland and Canada. This new continent discovery could also potentially be the key to how microcontinents form. What does this all mean, and what makes this hidden landmass near Greenland so important? Now, if you're like me, and if you are, then there's 2 of us, when you hear the word continent, you probably think of land like Europe or Africa, places above water where people live. But in science, a continent isn't about being above sea level. It's about what the land is made of. Earth's outer layer, called the crust, comes in 2 main types, continental and oceanic. Continental one is thicker, lighter, and made of different types of rock, like granite. The oceanic crust is thinner, heavier, and made mostly of dark volcanic rock. Now, the discovery under the Davis Strait between Greenland and Canada appears to be a piece of continental landmass, even though it's under the ocean. Scientists call it a proto-microcontinent because it began to break off from a larger terrain millions of years ago, but never quite made it. As tectonic plates slowly shifted, the Earth's crust in this region stretched and cracked. One chunk started to split away, but for some reason, the process stopped. It didn't drift off like a full continent, and it didn't sink like ocean crust either. Instead, it stayed right there, floating beneath the waves all this time. This makes it different from true microcontinents, like Zealandia, which have completely detached and now exist as separate tectonic blocks. Zealandia is a submerged microcontinent near New Zealand. About 94% of it lies underwater, but because it's made of continental crust, many geologists say it qualifies as Earth's 8th continent. However, Zealandia is still debated because it's too big to be a microcontinent, and there's no official global body to define its status. There's no global organization like the UN or some kind of international geology council that can declare, hey, this is a new continent. Unlike Madagascar, which is fully above sea level and widely accepted by geologists as a classic example of a microcontinent, Zealandia is still waiting for a proper label. I know you're probably wondering, isn't Madagascar an island? The simple answer is, it's both. It's the fourth largest island in the world, completely surrounded by water. But it's also geologically considered a microcontinent because it broke off from the supercontinent Gondwana around 88 million years ago and is made of continental crust, not oceanic crust. Unlike volcanic islands like Hawaii, this isn't just built from lava. It's a real piece of ancient continental crust. So Madagascar checks both boxes: island by geography, microcontinent by geology. And that's exactly why these discoveries can be fascinating. Just like Madagascar stands out above the waves, this newly discovered landmass under the Davis Strait stands out beneath them, thanks to its unusual structure. What makes it stand out is its unusual thickness. Most of the ocean floor is thin, like metal. This is more like packed clay, layered with continental materials. Underneath this cozy comforter, scientists discovered some odd layers of rock, unusual because they're not where they should be. These layers act more like the materials found on continents rather than those typically seen on ocean floors. There are hints of granite-like formations and distinct magnetic properties, which suggest that this stuff is similar to what makes up dry land. The size is also remarkable. The proto-microcontinent is about 12 to 15 miles across, which makes it roughly the size of a mid-sized city, like Manhattan Island that's 6,500 feet underwater. The fact that it sits right under the Davis Strait, one of the widest ocean passages on Earth, makes it one of the largest submerged continental fragments we've found. According to researchers, this landmass began to form between 58 and 49 million years ago, when Greenland and Canada were slowly drifting apart. Maybe they just weren't getting along. Hey, it happens. As they pulled apart, the crust under the Davis Strait stretched, and one of the main fault lines shifted. But the breakup didn't finish. Around 48 million years ago, the rifting stalled and Greenland's motion away from Canada slowed dramatically when it later bumped into Ellesmere Island. It's like a car swerving off and then back onto the freeway, a turn that was never completed. That's basically what happened. A chunk of land got stuck between the motion. It didn't float off into the ocean like a new continent, and it didn't get pulled down into the Earth either. It just stayed where it was, stranded beneath the water. But that's not all. This chunk has its own fault system, and scientists say it actually looks like a miniature version of the San Andreas Fault in California. Now, a fault is basically a crack in the Earth's crust where sections of rock slide past each other. Think of it as a place where the Earth's surface split and tried to slide sideways. In California, this movement still happens today and can cause earthquakes. But under the Davis Strait, it's a different story. The movement started, then suddenly stopped, like hitting pause in the middle of a big shift. It's a frozen moment in the planet's past, preserved right beneath the waves. For geologists, that makes the microcontinent under Davis Strait incredibly valuable. That sudden pause in motion helps explain why some chunks of land break away cleanly, while others twist, stall, or disappear. But this isn't just academic. By studying how continents break apart or stall, scientists can better predict future shifts in land, fault lines, and seismic activity. And predicting earthquakes and geological hazards could prove quite valuable to everyone. Knowing how microcontinents form could help us anticipate how the planet's surface might shift over millions of years, which affects everything from climate models to resource availability. But even just the technological advancement needed for such discoveries is greatly beneficial. The same tools used to map this hidden land are used for oil exploration, laying undersea cables, climate monitoring, and even search and rescue missions. Speaking of technology, for a long time, this hidden landmass near Greenland remained invisible. Just 10 or 15 years ago, the ocean floor under the Davis Strait was basically a mystery. It's deep, almost frozen, obviously not the easiest place to explore. But today, thanks to modern tools, a new continent discovery could be just a matter of time. Scientists can finally see and hear what's going on under all that water. First, they use seismic reflection imaging. That's a method where ships send sound waves down to the ocean floor and record how they bounce back. Various layers of rock reflect sounds in different ways, which helps build a picture of what's hidden underneath. It's kind of like how bats use echoes to see in the dark. Satellites also play a role in collecting gravity data. This may sound strange, but different types of rocks have slightly different weights. Heavier rocks create stronger gravitational pull, and satellites can measure those tiny differences. Another tool commonly used for these explorations is underwater sensors, which sit quietly on the seafloor and listen for natural vibrations, like mini earthquakes or shifts in rock. These vibrations help scientists figure out what the crust is made of and how thick it is. They're basically ears on the ocean floor. They also most likely used AUVs, or autonomous underwater vehicles, basically robot submarines that can scan the seafloor in high resolution even under thick ice. In any case, scientists are very excited because this new continent discovery is more than just a geological surprise. It's what they call a natural laboratory. The study of the microcontinent Davis Strait offers a rare opportunity to understand how microcontinents form, evolve, and sometimes fail to fully separate. It also reminds us that Earth's crust isn't as neatly divided as we once thought. Beneath the ocean, there may be other hidden landmasses near Greenland or elsewhere, almost continents just waiting to be found. This lost continent of Canada may not have made it as a fully fledged landmass, but its discovery is already reshaping how we view plate tectonics. And thanks to advances in technology, places we once ignored are now offering up secrets about the planet's deep past, and maybe even its future.
Not many civilizations are as mysterious as ancient Egypt, a powerful empire that lasted over 3,000 years. It gave us pyramids that still stand and myths that still inspire. It's one of the most explored places on Earth, yet somehow, we still find exciting stuff. In Abydos, archaeologists just uncovered a 3,600-year-old royal tomb. It's huge! It has golden hieroglyphs of deities covering the entrance. But the pharaoh's name? It's not there. It's missing. Who was this ruler? And what new chapter could this open in Egypt's story? If there's one place in Egypt where the line between life and demise feels thinner, it's Abydos. To the ancient Egyptians, this was sacred ground. They believed it was the burial place of Osiris, the god who literally passed away, had his remains separated, and came back to life to rule the underworld. Because of that, Abydos became Egypt's spiritual gathering place. Pharaohs built amazing temples here, like the Temple of Seti, famous for its King's List, a wall that has the names of 76 pharaohs carved in it. Pilgrims came from across Egypt, leaving offerings and participating in Osiris festivals, where his demise and rebirth were ritually reenacted. It wasn't just symbolic worship, it was Egypt's version of Comic-Con. But instead of cosplaying superheroes, people reenacted gods coming back to life. Obviously, pharaohs competed to be buried as close to Osiris as possible. Abydos became part cemetery, part holy city, part afterlife insurance policy. Fast forward thousands of years, and we still uncover remarkable stuff around Abydos. That's the case with the recently discovered tomb. In early 2025, a joint team of researchers from the US and Egypt decided to dig beneath a rocky rise ominously called Anubis Mountain. You remember Anubis, the jackal-headed deity who guarded cemeteries. The uncovered royal burial was hidden 23 feet below the surface. Sadly, even though it eluded archaeologists for so long, robbers had already taken away with treasures ages ago. They could definitely tell this was a tomb of someone super important. Similar to how you can walk around a mansion with no furniture but still deduce that someone rich must have lived there. The chamber had mud brick vaults rising over 16 feet. That's taller than a female giraffe standing upright. For something built 36 centuries ago, it still felt enormous. However, when you remember that Egyptians were masters of architecture, nothing seems surprising. So no treasures, no golden mask, and sadly, no name. The cartouche that should have spelled the king's identity was unreadable. Egyptian tombs usually bragged about who was inside. In ancient Egypt, a cartouche was basically a big oval name tag for kings wrapped in hieroglyphs. Think of them as VIP passes that worked in both this life and the next. Without it, your soul couldn't check into the afterlife hotel. That's because to the Egyptians, your name, your Ren, wasn't just so your teacher could distinguish you from kids with the same haircut. It was a core part of who you were. As long as your Ren survived, so did you. To have your name forgotten was considered a fate worse than passing away. A soul cannot journey without a name. That's why you'd see cartouches all over the place, on temples, obelisks, jewelry, statues, and tomb walls. It wasn't there just for the marketing. It kept the pharaoh's presence front and center everywhere you looked. Imagine building a massive tomb only for 3,600 years later to walk in and go, who is this guy again? Not cool at all. That's why it's fair to imagine our nameless pharaoh haunting the robbers for all eternity. So yeah, cartouche was considered very significant. One of the most famous and mind-blowing examples comes from the tomb of Thutmose III. His burial chamber and sarcophagus were literally shaped like a cartouche. In other words, the entire room was a living architectural symbol of his name. Thankfully, in the recently discovered tomb, not everything was erased. Painted in golden hues at the entrance were two familiar guardians, deities Isis and Nephthys. Isis was the magician who stitched Osiris back together and breathed life into him. Nephthys, her sister, was the eternal mourner and protector of the mummy. Together, they promised that whoever rested here would not face the afterlife alone, and it's one additional proof of the importance of the mysterious pharaoh. So, who could this be? To answer that, we need to go down history lane. This tomb dates back to Egypt's messy chapter called the Second Intermediate Period. Instead of one ruler in charge, the country had many rival kingdoms, each with its own little power base, like a real-life Egyptian version of Game of Thrones. And right in the middle of that chaos was Abydos. For a while, it was home to its own line of kings, the so-called Abydos dynasty. Those weren't the pyramid builders everyone knows, and that's why they're so mysterious. They left behind almost nothing. No great monuments, no sprawling cities, just fragments of names on broken blocks. For centuries, many scholars even doubted they existed at all. That sorta changed in 2014, when archaeologists uncovered the tomb of Senebkay, one of those shadowy kings. Now, everything we know about Senebkay points to him having quite a story to tell. His bones revealed 18 deep wounds, the kind you get in battle. He had blows to his skull, back, and hands, and likely lost his life fighting, making him one of the few pharaohs we know who sadly fell in combat. His tomb was modest, with reused artifacts from earlier kings, but it delivered one priceless thing: proof. Until Senebkay, the Abydos dynasty was just a theory. With him, it became real. And that's why the new discovery could be a big deal. The newly uncovered royal tomb at Abydos shares the same layout and style as Senebkay's. It has limestone chambers, mud brick vaults, and protective deities, although it's much bigger. Which again raises the possibility that we're looking at an even earlier, more powerful ruler of Abydos. Whoever he was, he wanted to be remembered alongside the greats. Which is ironic, because it seems that history tried erasing him. Perhaps additional findings alongside his tomb could tell us more. Yes, there's more, and it's actually pretty cool. Not far from Abydos, in the village of Banawit, archaeologists uncovered a Roman-era pottery workshop. Yeah, you heard that right, a pottery factory close to a pharaoh's burial ground. The site had huge clay kilns, storage rooms, and even broken shards called ostraca. They were basically ancient sticky notes. Except instead of shopping lists, those had receipts scratched onto them in Greek and Demotic Egyptian. Little records of everyday transactions, the kind of thing you'd never expect to find near a lost dynasty king. Honestly, the potters missed a chance. Forget boring receipts, they should have been selling Osiris's mugs and Anubis figurines to pilgrims and tourists. But that's not all. It seems that centuries later, during the medieval period, the same ground became a cemetery. Archaeologists found mud brick graves with skeletal remains. This could mean that Abydos kept its aura of significance for hundreds of years after the Age of Pharaohs. So why this hill again and again? Is this place really a getaway to the afterlife? It is, after all, the very place where Osiris is said to rest. That belief lingered like a shadow for thousands of years, strong enough to pull in pharaohs and later medieval families. Different rituals, same sacred ground. Although, to be fair, the Romans weren't here for Osiris. They came to make pots. The story of Abydos is not over. The excavations will continue, and who knows what else could be discovered in the future. Today, archaeologists are armed with tools that are basically X-ray glasses for the desert. Every scan could reveal a hidden chamber, or if we're lucky, finally give our nameless pharaoh his wren back to him. In fact, I became strangely invested in finding out who he was. So let's hope for some news soon. It's only a matter of time. Do you have your own theories? Let me know.
Psst, a giant is hiding in the sky. Quipu is the biggest thing we've ever found in the nearby universe. It's been messing with our understanding of the universe for years, and we've just discovered it. Quipu is dense, powerful, and dangerous to ignore. If we don't understand structures like this, we might be reading the universe completely wrong. So, what exactly is it? It's not a solid object like a planet or a star, and it's not a single thing. It's a superstructure, basically an entire region of the universe, a tangled mess of matter spanning a huge amount of space stitched together by gravity. Quipu is made up of an enormous web of galaxies, galaxy clusters or giant groups of galaxies, gas and dark matter. It's like a superhighway, with galaxy clusters being the cities, filaments being the roads, and dark matter being the invisible infrastructure holding it all together. This giant stretches across 1.3 billion light-years. That means if you traveled at the speed of light, it would still take you 1,003,000,000 years just to cross it. Quipu also holds 200 quadrillion solar masses, even though it only takes up 13% of the observable universe. The name Quipu comes from the Incan system of knotted cords used to record things, called quipus. It was like a writing system. In that system, each knot, color, and twist told a story, numbers, taxes, harvests, and so on. So, when astronomers saw this colossal structure in space, long, tangled, and branching like space cords, they named it after this language of knots. Plus, the shape of the space reminded scientists of those threads. There's a long central filament, and the smaller ones are branching off the sides. What's even more fascinating, Quipu isn't alone. When scientists mapped this part of the universe, they found 5 of these massive structures. They aren't just sitting there either. They formed over billions of years through gravity slowly pulling matter together. All told, all those giants hold nearly half of all the galaxy clusters in that region, 30% of all the galaxies, and a quarter of all the matter in the observable universe. The team that found Quipu used a clever trick. They searched for X-rays coming from galaxy clusters. These clusters aren't just full of galaxies. They're also filled with superhot gas. That gas is so hot it glows in X-ray light, which we can't see with our eyes, but special telescopes can. If there's a lot of that X-ray glow, it means there's a huge amount of matter, galaxies, gas, and dark matter all pulled together by gravity. That's where the densest, most crowded areas of the universe are. So, by following the X-ray glow, the scientists could draw a map showing where the biggest cosmic structures like Quipu were hiding. Why does any of this matter? Because these megastructures mess with everything. First of all, they warp the cosmic microwave background, the ancient light left over from the Big Bang. It's a faint glow of light that fills the entire universe. After the Big Bang happened and our world was created, it emitted its very first light and signals that still haven't completely weakened yet. The leftover radiation is still coming to us, even after 13.8 billion years. By studying this ancient light, scientists can learn what the early universe looked like, and Quipu ruins it for us. These megastructures hold so much gravity that they bend and distort this ancient light as it passes through them. That's called the integrated Sachs-Wolf effect. These warps add noise to the original signal, and now it's harder for us to get a proper, clearer understanding of what the baby universe looked like and how it expanded. They also mess with the Hubble constant. The universe is constantly expanding, and the Hubble constant tells us how fast it's growing. In other words, how quickly galaxies are moving apart from each other. But giant things in space, like Kipu, have so much gravity that they pull nearby galaxies toward them, messing up the way those galaxies move. This makes it harder for scientists to measure the universe's true speed of expansion. They can't tell if a galaxy is moving because of the universe growing or just because it's being pulled by something huge nearby. And finally, there's gravitational lensing. Light in space travels constantly, but it doesn't always follow a straight line. If the space gets distorted, like by gravity, then the light traveling through the space will get bent and distorted too. Gravitational lensing is when light from faraway galaxies gets bent because it passes by something supermassive, like Kipu here. That huge gravity pulls on the light, like how a heavy ball can bend a sheet. And since light delivers information to us, literally makes us see what things look like, this bending distorts how we see galaxies. The images of galaxies end up looking stretched, brighter, or we can even find an entire galaxy in the wrong place. It's like looking at our universe through a warped magnifying glass. If we're not careful, we could misread those distortions and get the wrong idea about what our world looks like. Luckily, we didn't just drop these mysterious superstructures out of nowhere. Astronomers suspected that something like that should be out there. They just didn't know for sure. Our best model for the universe is called Lambda CDM. It says, universe started with the Big Bang, is still expanding, and is mostly made of mysterious stuff, dark energy, and cold dark matter, the CDM part. We can't see or touch these things, but we know they exist, because if they didn't, our universe would literally break apart. This model matches what we do see, like galaxies forming, how stars move, and the overall shape of the universe. So even if some puzzle pieces by themselves are still a mystery, they match the actual picture. And this model actually predicted things like Kipu. When scientists ran simulations using that model, they saw similar structures forming, giant cosmic webs of galaxies tied together by gravity. Kipu matched those predictions in real life. This also means that Lambda CDM is matching real life once again, thank heavens. No huge surprises here. But now that we actually found it, it's the largest known structure in the observable universe. There was another giant before Kipu, the Sloan Great Wall. That one was discovered in 2003 and was believed to be one of the largest structures ever found. And it's still an absolute monster. The Sloan Great Wall stretches over 1 billion light-years across. It's called a wall, but it's not like a wall you'd find on Earth. It's also a vast cosmic web, made up of thousands of galaxies and gas connected by dark matter. What makes both Kipu and the Sloan Great Wall so surprising is that they literally seem too big to exist. According to the Lambda CDM model, structures that huge shouldn't be common, especially at the time they formed. How did these giants form so fast in a universe that's supposed to be growing, expanding, and smoothing over time? And if we keep finding more of them, that would be completely insane. It could mean there's something deeper going on in the way our world is built. It's all part of our crazy Copernican journey, a long series of discoveries where we just keep getting humbled by the universe. Every time we find something like this, we realize even more how we're not the center of everything. First, we learned the Earth wasn't the center of the solar system. Then we found that the solar system is just one speck in a galaxy. Now, even galaxy superclusters, which we believe to be the biggest, are being dwarfed by structures like Kipu and the Sloan Great Wall. But also, these structures won't last forever. Kipu is temporary. Over billions of years, gravity will tear it apart, breaking it into smaller pieces. Some parts will collapse into tighter clusters, others will drift apart. Right now, though, it's one of the most important structures in the known universe. It shapes how galaxies form. It bends light, making it super important for us to decipher. It literally messes with our understanding of the cosmos. Scientists found an entire city of Gaiangola that was hidden beneath the dense jungles of Mexico for 600 years. It covers 360 hectares, had over 1,000 buildings, 2.5 miles of defensive walls, a network of internal roads, and a well-planned urban layout with temples and ball courts, and separate neighborhoods for the elites and commoners. For centuries, people believed there was just an abandoned fortress there, based on stories passed on from generation to generation. Until recently, there was no way to see how truly huge it was without spending years on the ground. But thanks to the new technology, a remote sensing tool called LiDAR, they got a 3D model of the area in just 2 hours from a plane. Gaiangola was built between the years 1350 and 1521. It was a crucially important place for the Zapotec people, a group that had lived in the area since around 700 BCE. In Gaiangola, families lived together in homes with big patios in the middle, surrounded by rooms. When families got bigger, they built more rooms and made their homes larger. The study found that both the leaders and regular people worked together to make the city better. Because Gaiangola was surrounded by mountains, they used this land wisely and built their houses in a way that fit the slopes and let rainwater flow naturally. This helped keep their homes safe and strong. They were built so well that many of these buildings are still standing, even after hundreds of years. There are 2 pyramids in the center of the city. They may have been used as temples where the priests celebrated rites and ceremonies to their deities. The priests brought offerings to the altars, and the people assembled at the 2 squares that are now sunken. Then, there is also a palace with 64 rooms, some of them with circular columns on several sloped terraces. There are patios with many stairways all connected to each other. The sensing tool also found a round-shaped lookout point on a natural rock, where the Zapotec people could see their foes approaching from a distance. Researchers also noticed 2 circular structures that could have been used to watch the stars and measure time. They also found some tombs, so there was most definitely a city cemetery. By the end of the 1400s, the Zapotec people controlled a large territory on the Pacific coast and had successfully defended their land from the Aztecs, who were trying to take over more territory. They did the almost impossible and survived a 7-month-long siege at Gaiangola. When they won this conflict and kept control of the southern part of Mesoamerica, the Zapotecs didn't need to live in Gaiangola anymore. Staying in the mountains had its pros, but they needed fresh water and good farmland to grow food. The small city of Tehuantepec, just 12 miles away, had these conditions, so they moved there just before the Spanish arrived in 1521. Over time, Zapotec traditions started to fade, but their culture didn't disappear completely, and more than 300,000 Zapotec people still live in Oaxaca State in Mexico. They speak their own languages and keep their traditions alive. Creating the 3D model of the lost city is just the beginning of the research. Archaeologists hope that future studies of Gaiangola will help us learn more about how the Zapotecs were organized, how they ruled their cities, and how they interacted with the Spanish when they arrived. They plan to study all 1,100 buildings found in the LiDAR scan, and it will take a few years. Instead of digging up the ruins, they will use special technology to scan the land and learn more about the city without damaging it. This same tech helped scientists find another massive ancient city that lay hidden beneath the thick green canopy of the Amazon forest. A whole network of houses, plazas, roads, and canals was hiding in the shadow of a mighty volcano. For centuries, many scientists assumed that ancient Amazonian people lived in tiny huts, clearing patches of land to survive. But this city, built 2,500 years ago and inhabited for 1,000 years, proves the opposite. Now, scientists think tens of thousands or even hundreds of thousands of people lived in complex urban societies. Scanning the area found 6,000 rectangular platforms, each measuring around 66 by 33 feet, and standing 6 to 9 feet high. These structures were arranged in clusters around central plazas, with straight roads with perfect right angles and paths connecting them. One of the roads was 16 miles long. Building straight roads like this is far harder than just following the landscape. Some of these roads may have had deep spiritual or ceremonial significance. The volcano's rich soil helped the civilization thrive, but it may also have led to its downfall. Researchers also found signs of threats to the cities, such as ditches that blocked entrances to the settlements. Maybe some people living nearby were trying to get in. The next step for the researchers will be studying the adjoining 116 square miles to know more about this large, complex society that could be bigger than the well-known Mayan societies in Mexico and Central America. Meanwhile, in 1963, a man in Turkey discovered an ancient city while renovating his own house. He knocked down a wall in his basement and found a mysterious room. He kept digging and saw a tunnel. It led to the Derinkuyu underground city. It's one of the deepest multi-level underground settlements in Cappadocia and in all of Turkey. The inhabitants lived on 8 levels and had access to cellars, storage areas, chapels, a school, a study room, and other structures. All floors were connected by an extensive network of tunnels. The underground city was probably built as a shelter. The construction is hiding at 279 feet deep, and you can't see it from the outside. The complex was large enough to shelter about 20,000 people with their livestock and food supplies. There was also a 180-foot ventilation shaft. Archaeologists believe that Phrygians first built the levels. The Romans used and enhanced the structure later. The golden time of Derinkuyu was during the Byzantine era. The next lost and found city appeared only in a few inscriptions and ancient texts, so no one could be sure it really existed. Scientists searched the majority of the coast of Egypt, until one archaeologist and his team detected a colossal face looking at them from under the water. The ancient city of Thonis Heraklion was discovered completely submerged 4 miles off Alexandria's coast. In the ruins of the lost city, there were 64 ships, 700 anchors, and a treasure trove of gold coins. Archaeologists believe the 16-foot-tall statue and the temple remains are the most important findings discovered by the expedition. Back then, the city had ceremonies and celebrations that took place in the Temple of Ammon. The ruins and artifacts were made from granite and diorite, so they were in good condition even after having been in contact with water for centuries. They give people a glimpse into what life was like 2,300 years ago in one of the most important trade ports of the world. The city had a network of canals, sort of like an ancient Egyptian Venice. The canals linked many separate harbors and anchorages. Towers, temples, houses, and other structures were also linked by bridges. Thonis Heraklion was the country's main port for international trade and the collection of taxes. No one really knows how the city ended up submerged, but archaeologists connect it with natural causes. At the end of the 2nd century BCE, most probably after a flood, it got covered with water. Then Alexandria, the city founded by Alexander the Great, became more glorious than Heraklion. Before Alexandria's fame, Heraklion was the main port of entry to Egypt. So after the tragedy, many ships heading for Heraklion had to change their route and go to Alexandria. Heraklion lost its glory until its discovery in 2000. Scientists have found an invisible star at the Milky Way center, a star that helped our galaxy be born. 26,000 light-years away, in the galactic center, a massive, invisible object started spreading everywhere, and you don't even know that you're breathing it right now. It all started in the 70s, when an astronomer named Vera Rubin was studying the Andromeda Galaxy. She decided to check whether stars move in a predictable way. Now let's say you're spinning a ball on a string around yourself. The closer the ball is to you, the faster it moves in a tight circle. But if you let the string out longer, the ball moves more slowly in a bigger loop. That's how gravity works. And the same goes for planets. The closer ones, like Mercury, zoom around quickly, completing their orbits in months. The far ones, like Neptune and Saturn, take their time, decades, to make one rotation. The stars themselves should orbit the centers of their galaxies the same way. The closer ones move fast, the farther ones are slower, right? But when Vera measured the speeds, she saw something impossible. They weren't slowing down. The faraway stars were moving just as fast as the ones near the center. By all logic, the galaxies should have torn themselves apart, but they didn't. And that meant something was holding them together, something undetectable, some massive invisible object in the galactic center warping reality without ever revealing itself. So she checked over and over with different galaxies. This wasn't a fluke, it was happening everywhere. Rubin had accidentally uncovered proof that galaxies were drowning in something far heavier than all the stars, planets, and gas in our entire universe combined. It was holding us with ghostly hands. Astronomers called it dark matter because it doesn't glow, doesn't reflect light, doesn't seem to interact with anything at all. It's just there. But all the calculations show us that it exists, and not merely exists, but makes up 85% of all the mass in the universe. We know that it sculpted galaxies. Without it, the world as we know it wouldn't exist. And yet, just like with an invisible star scientists found at the Milky Way center, the only way to detect it was through gravity. So how do you find something that refuses to be found? Recently, scientists discovered there might be an invisible star at the Milky Way's center, and this fascinating discovery might finally help us understand what dark matter looks like. They began looking for dark matter's fingerprints, any signs of its presence anywhere. They studied how galaxies moved and smashed particles together in giant machines, hoping to create tiny bits of dark matter in the lab. This didn't really lead to anything. They didn't even know what to look for. Is dark matter even made of particles? There was a theory that suggested that it's made of ghostly particles that barely touch anything, or even weirder ones that might flicker in and out of existence in the blink of an eye. There was a problem, though. If dark matter really worked like that, then the centers of galaxies should be packed tight. Tons of matter would be crammed into a tiny space. But in our universe, galactic cores seem strangely soft, spread out, almost gentle. A new theory emerged, and it was wild. What if the dark matter at the heart of galaxies isn't made of heavy particles at all? What if it's made of something so delicate that it behaves more like a strand of hair? These hairs could be made of something incredibly light, lighter than anything we've ever seen, and billions of times smaller than a neutrino, which is already the lightest known particle. They called this idea fuzzy dark matter, and it might change everything we thought we knew about the universe. A team of astrophysicists wanted to test this idea, so they ran a simulation, creating a simple model of a galaxy with two main ingredients: a whole lot of fuzzy dark matter and a little bit of gas, the same kind of gas that forms the stars we can see. They pressed start and just let the system evolve by itself, watching how the two would interact. At first everything was pure chaos, but then the fuzzy dark matter started to gather. It pulled itself together, forming a massive invisible object near a galactic center. The gas followed, spreading throughout this ghostly mass, mixing with it and glowing faintly. And then it suddenly formed something incredible: dark stars. Not typical stars like our sun, blazing with heat and light. Instead, it's enormous, massive, invisible objects, a hybrid of two different kinds of matter. We've never seen anything like this before. An object that would stretch across thousands of light years, and yet they'd be almost weightless, more like cosmic puffy clouds than anything else. Scientists called them Fermion boson stars. Finally, this dark matter thing is starting to make sense. The core of this strange invisible star would have just the right density, not too dense, not too loose. And it looked exactly like what astronomers actually see in real galaxies. If it's confirmed, then it would finally explain how dark matter behaves and works. And if they're right, then every galaxy in the universe could be tied to one of those vast unseen giants. The Milky Way hidden star might be one of them, shaping our galaxy in ways we never realized. What's wild is that this stuff wouldn't behave like normal matter. It wouldn't form anything solid. Instead, it would be more like a complex, ever-moving web of filaments or hairs. This also means that Earth might be completely surrounded by it. Dark matter still follows the rules of gravity. As it moves past planets and stars, gravity pulls it into focused streams, so it's both hugging and passing through our planet, wobbling consistently. If we could see them, they might look like glowing invisible threads everywhere, and they'd pierce right through the planet, stretching far into space. But this is only the beginning. Now scientists need to refine their models, make them even more detailed, and compare their predictions to real galaxies. But this dark star discovery in the galaxy's center isn't our only clue. Luckily, the universe has given us a way to look for that fingerprint – gravitational lensing. When light from a faraway galaxy travels toward us, it sometimes passes by another massive galaxy on the way, or other massive objects with crazy gravity. Instead of continuing in a straight stream, light actually gets bent around the massive object because of that gravity. And when it finally reaches us, it creates a distorted and magnified version of the original galaxy. Basically, it's like looking through a piece of curved glass. If dark matter is fuzzy, then it should leave a strange pattern on these distorted images. Things should be a bit wavy and unclear. Scientists needed the perfect object to study this, and they found one. A faraway galaxy whose light was bent by gravity, creating a strange stretched-out image. They used super-powerful radio telescopes, connected them all over the world, and turned them into one giant telescope as big as the Earth itself. With this, they could zoom in so much that they could see details of that galaxy as tiny as a grain of sand on the moon. Then they ran a huge experiment. They created their own fake versions of this picture, simulations with various sizes of fuzzy dark matter particles. And at a certain point, they found the perfect match. This helped us calculate the exact mass of dark matter particles before we even detected them. And the clues are leading us right to our own galaxy. It seems like densest parts of these hairs, the roots, might be super close in the cosmic scale, just tens of thousands of miles from Earth. That's close enough for a space probe to reach. Now that scientists have found this invisible star at the Milky Way center, we just need to study it up close, send a mission to one of these roots, and then we might finally crack the greatest space mystery of all.
A Portuguese archaeologist just discovered a bunch of sunken ships filled with gold, including a Spanish galleon with 22 tons of gold and silver. This much gold today is worth about $2 billion, and this is the money from one ship alone. Archaeologist Alexandre Monteiro made this discovery almost by accident. He was studying some documents when he found some information about a ship that went missing in 1615, and he decided he wanted to find it. After many years, Alexandre found not just this specific ship, he actually discovered 8,620 shipwrecks in the waters of Portugal alone. Out of this number, 250 are gold-filled shipwrecks, a discovery that would make any Jack Sparrow shake in his boots. Most of these ships went down for boring reasons like the weather, but sometimes they were destroyed in battles, which may or may not have been super epic. They were carrying gold and other treasures from the New World to Europe, and of course, everyone wanted a share. Alexandre had been studying historical shipwrecks for 30 years now, so he has discovered many ships that went down in somewhat glorious ways. In 1816, for example, a ship of one of the richest men in Portugal sank in Australia, with an insane amount of 66,000 silver coins. This was the first ship from Portugal to ever plunge in the waters of Australia. The bad news is that these ancient sunken vessels, filled with riches and epic stories, are not so easy to reach. They're deep down in the ocean and covered by sand. You could still try, but that would be stealing part of a country's history, and you wouldn't want to be that person, would you? Naturally, Portugal was not the only country that explored the seas back then. The coast of Europe is packed with sunken ships filled with gold. In fact, there are about 1 million historical shipwrecks underwater right now, and the treasures abandoned under the sea might be worth around $60 billion. It's an insane amount of money, but let me tell you that these gold-filled sunken ships aren't really worth the hassle. There are many stories of maritime treasure discoveries that turned into insane lawsuits and even long jail time. Our first story starts in 1746, when a violent storm crashed a ship called Prince de Conti near an island in Brittany. The ship was filled with tea, ceramics, and 100 gold ingots. Of course, the owners of the ship tried to save the loot, but if it's not easy now, imagine how it was back in the 18th century. It took more than 200 years for the vessel to be found. It finally happened in 1975, when a group of French men discovered it and decided to take pretty much every valuable thing they could find. Now, I said these things were not worth the trouble for a reason. In France, if you find anything that can be historical, you must declare it to the local authorities within 48 hours. Fail to comply, and you will be committing something known as a crime. To be fair, our French friends here did declare their findings, but only the corroded cannons from the ship. And the gold? Well, they sold it. Obviously, because each gold bar is worth between $125,000 to $231,000. It took French authorities almost 50 years to retrieve the stolen gold, and they didn't retrieve all of it. Part of it was bought by an elderly couple living in Florida, and the crime is so serious they were charged for connection with money laundering, organized crime, and the trafficking of cultural goods. The poachers also sold some gold ingots to the British Museum collection. Now, let's go back to the 1850s, when a steamer called SS Central America traveled from Panama to California and back again. This was during the California Gold Rush, a time when 300,000 people moved to California to dig for gold. Because the travel route was not easy breezy, people needed to carry their gold around on big ships. This is where our friend SS Central America comes in. In 1857, the ship had 578 people on board and about 10 tons of gold. Very few survived, and around $100 to $150 million in gold went down with the ship. All of this explains why in 1988, a group of investors from Columbus decided to finance a research project to find this ship. The research was led by a guy named Tommy Thompson. Tommy was really crazy about the idea of finding this sunken ship filled with gold. It took him years to find the exact location of the SS Central America, especially because the ship was 7,500 feet beneath the surface of the Atlantic Ocean, and retrieving it required a lot of fancy tech. A group of 161 investors paid for his adventure, but it goes without saying that they were not doing this out of love from their hearts. They invested $12.5 million in this project because they were expecting to earn at least 10 times more. But since life is not all sunshine and rainbows, 39 insurance companies sued the research team as soon as they retrieved the gold. Back when the ship was up and running, these companies insured the cargo of the SS Central America, and when the cargo was finally retrieved, more than 100 years later, they wanted to be compensated. They said it was not their job to retrieve it, but that doesn't mean they abandoned it. This crazy talk didn't stick, and 92% of the gold was given to the research team. The plot thickened when the investors were scammed by none other than Tommy Thompson, who fled with $4.16 million. He also had 500 gold coins, but he's not telling a soul where they are. Nonsense like this is the reason why most countries have rules to protect cultural properties. And yes, sometimes shipwrecks can be a cultural property. Obviously, there are many maritime treasure discoveries that happen without breaking any laws. The SS City of Cairo, for example, was a steamship that submerged in 1929 with 2,000 boxes of silver coins weighing 122 tons. A company called Deep Ocean Search retrieved the coins from a depth of 17,000 feet, which is 4,500 feet lower than the Titanic. 34 million pounds went to the UK Treasury, and the Deep Ocean Search also got a share. The good news here is that some of the coins can be bought by collectors, legally. Paying for a treasure is probably the closest you can get to an underwater archaeology find. I know, all I did was destroy your piracy dreams. But while raiding gold-filled shipwrecks may be a crime in most countries, or just financially impossible for us mere mortals, not all hope is lost. There is about $771 trillion worth of gold lying on the ocean floor, and it doesn't have an owner. It's like an underwater gold mine, except the gold is in the water. You know how the water of the ocean is salty? Well, the gold gets mixed with the minerals in the water, so it's not like you stumble upon a gold nugget on the beach. Each liter of ocean water has 13 billionths of a gram of gold, and it's very difficult to extract such tiny particles of gold from the water. But that doesn't mean people haven't tried, and, of course, there's been a scam here too. In the 1890s, a guy claimed he had invented a thing that would suck gold from the seawater. When he got enough money, he fled the country with the cash. If you really want to get some gold, you could try to extract it from the Earth's core, which has 1.6 quadrillion tons of gold. There's 16 times more gold in the Earth's core than what humans have mined in the whole of history. No hoax involved here, because nobody has dared to go down there yet. With archaeologists discovering gold-filled sunken ships out and about, maybe we can make our own maritime treasure discoveries, or at least save enough money to buy some silver coins.
Let's talk about some unusual drawings. You've probably heard about those large geometric patterns on fields made by spacecraft from other galaxies. They're fake. The circles were drawn by people to attract attention. You might also know about cave paintings that our distant ancestors made to express themselves. Awesome! And still, there's nothing unusual about it. But have you ever heard of strange patterns on the seabed? Do you know what's so strange about them and who created them? Scientists know for sure that they weren't drawn by humans. The deeper the water, the less mobile it is. On the surface or in shallow places, constant currents move the water, carrying nutrients and changing the floor's landscape. But at depth, under very high pressure, these currents are slower. If someone paints a picture on the seabed or swims by touching the sand with their body, those footprints will probably remain there for a long time. It's such patterns that help scientists understand how different marine life moves, how it feeds, how it reproduces. In a word, how they live. These patterns may look like winding paths, circles, or small pits for storing food. Marine researchers mostly know the cause of these footprints, but what they found at the bottom of the Fram Strait between Greenland and Svalbard stunned them. They conducted deep-sea surveys of this region. Scientists sent remotely operated vessels into the depths. Using those machines, they took pictures of the seabed and noticed 106 strange octagonal structures. They were quite strange and kind of beautiful. But what animal could leave this pattern? And most importantly, for what purpose? Scientists suggested that those octagonal footprints might show prey handling. That is, some creature did something with its prey and left such patterns. Was it stalking? Or did some animal grab its prey tightly and drag it along the seabed? The scientists wanted to know for sure. Some of the octagons were grouped, others were separated. After analyzing the images, the researchers came to the conclusion that those patterns were left by Dumbo octopuses. These amazing creatures with jelly-like bodies are inkless and have a pair of large lop-eared fins on their heads. Pretty cute creatures. After the scientists found out the nature of the drawings, they began to study the cause. Why did Dumbo octopuses leave these patterns? The researchers observed them and discovered a strange feeding sequence that was repeated in a circle to catch prey. This sequence included spreading, enveloping, retreating, and flapping fins frequently. Look carefully. First, the octopus slowly floats over the seabed. They're extending the tentacles parallel to the ground. Then they spread their webbed tentacles and grasp the ground beneath them to reach the food. They also flap their fins to catch food that might end up between them and the seabed. After that, they swim off into open water. Their way of extracting food has a scientific name: pelagic benthic feeding. It means they're swimming in the open water and feeding on the bottom. Scientists probably enjoyed watching octopuses because these creatures weren't afraid of the vessels that recorded their hunting process. Moreover, the animals showed curiosity and even swam closer to the camera. And then they sailed away in an umbrella pose. Okay, we've seen patterns that appear because of an unusual way of getting food. Let's now move over to the Japanese coast. Here, on the seabed, you can see amazing geometric designs made for a purpose: to find love. Meet this handsome guy called the pufferfish, also known as fugu. You've probably heard that this fish is poisonous and it's very dangerous to eat it, but you probably didn't know that it painted pictures on the seabed to attract females. A pufferfish male swims above the bottom, flapping its fins on the surface and thus drawing a really beautiful pattern. Then it finds pieces of shells or some kind of trash and decorates the created maze with this stuff. Such a tiny fish the size of a human palm is painting a masterpiece bigger than a round double bed. It works hard to perfect every line, and it's been at it for over a week. But why? To impress the love of its life. If a female pufferfish likes the pattern, then they create a family together. In the middle of this circle, the female lays eggs and then swims away. The male takes care of the eggs until they hatch, but this is an open area. How can a small pufferfish protect its offspring from predators? Well, not only people know about its poisonous properties. The toxin in this fish keeps big predators away, so no one dares to touch it. If the female doesn't like the drawing, it swims away and the poor male is left with a broken heart. The sea current soon washes away the drawing. The fish, after a while, draws a new one and tries to make a family again. But why is it only this fish that draws these patterns? How does its brain work while making this maze? Does it feel aesthetic pleasure creating it? Scientists don't know. The behavior of these fish is very similar to that of bowerbirds. These animals also love creativity. They build beautiful huts from branches and leaves. Then they decorate them with flowers, berries, and basically anything beautiful they find. And they do this to attract females. Fish create beautiful nests on the seabed, birds create beautiful huts for the same purpose. It's fascinating that these creatures are not so different from humans. So, let's move on to our next drawing. This time, you're unlikely to guess who made it. So, in 2013, a photographer used a drone near the town of Nelson in British Columbia to take pictures. He got beautiful shots of forests, lakes, landscapes, and something strange. The drone caught a maze of unknown origin that was located under the surface of Kootenay Lake. The maze was made from stones on the lake bed near the shore, and it was big enough, but it's unlikely that any marine life would be able to collect all those stones in one place. Then, what is it? The guy who found the maze posted it online. Users immediately assumed that it was a petroglyph, an image carved by ancient people into stone. Petroglyphs can be found all over the world, but this Kootenay Lake maze was clearly not set in stone. Theories began to appear on the internet. For example, that the maze was made by indigenous peoples or visitors from other planets. And there was also a version that it was created by a Bigfoot. The truth wasn't that exciting. Professors from the Department of Anthropology at the University of British Columbia joined the conversation. The first thing they did was reject the petroglyph theory. Petroglyphs, they said, were images etched or carved into the surface of rocks, and that maze is just stones lying close to each other. Professors suggested the maze was created during low tide, which had occurred recently. Later, another photo appeared with a similar maze, but without water. Obviously, it was done by people who were just bored. Nothing ancient, nothing extraordinary. Here's another example. In the North Caucasus city of Kislovodsk, strange stone towers stand on the shore of a local river. Stones of different sizes and shapes lie on top of each other, forming low towers. They look unnatural. It seems that they're about to fall, but they've been standing there for weeks and even months. Perhaps they're glued to each other, or an iron rod passes through them. In fact, they really stand on top of each other and anyone can easily break the towers. But how is this possible? A local artist with an amazing sense of balance carefully builds these stone sculptures. Slowly and patiently, he finds the perfect angle and position for each stone before stacking it on top of the others.
Now this bad boy was the size of a husky and could maybe pass for one, except it didn't have any fur and was a top predator with extra long blade-like canine teeth. Ooh, charming. Meet the earliest known saber-tooth animal to have ever lived. It roamed the Earth well before the dinosaurs. Scientists made the description of this creature based on its fossils found on the Spanish island of Majorca in the Mediterranean Sea. About 200 million years ago, none of us were around then, the very first true mammals appeared, and they lived right alongside the dinosaurs. But if we trace the family tree of mammals even further back, we'll find an ancient group called Therapsids. They didn't look like mammals we have today, but they had some key features that would eventually help define mammals. For example, Therapsids had special openings on the sides of their skulls for jaw muscles, and parts of their jaw bones would later evolve into the tiny middle ear bones that all mammals, including you, have today. So, the new discovery is what might be the oldest known Therapsid fossil. The fossil, which doesn't have an official species name yet, belongs to a group called Gorgonopsians. Those guys are more closely related to mammals than they are to any other living animals. Some of them were as small as cats, and others were as massive as polar bears. Gorgonopsians had some very mammal-like traits, like different types of teeth for different jobs. But unlike mammals, these ancient predators kept replacing their teeth, even their giant saber-like canines, over and over during their lives. Hey, that would be handy. Until now, the oldest Gorgonopsian fossils we knew about were around 265 million years old. But this new fossil is even older, dating back between 270 and 280 million years. The find was super detailed and complete, including its sharp knife-like fangs, part of its jaw, pieces of its spine, ribs, tailbones, and toe bones, plus most of one of its back legs. Even though the creature's skull wasn't complete, the scientists think it was about 7 inches long, and the animal itself would have been around the size of a medium-large dog, weighing between 66 and 88 pounds. But other than that, it didn't really look much like a dog. Even though it had some lizard-like features, calling it a lizard dog is totally wrong. Mammals and reptiles do share a super ancient ancestor from about 320 million years ago, but their evolutionary paths split a long time ago. When the newly found creature was alive, the island of Majorca was right in the middle of the gigantic supercontinent Pangaea. Back then, this area went through super wet and super dry seasons. Scientists have always wondered if major moments in mammal history happened in tropical places like this, but we just didn't have the right fossils to prove it. Now, with the discovery of the oldest known Gorgonopsian in Majorca, the missing pieces of the puzzle are coming together. It looks like some huge steps in mammal evolution could have happened in low-latitude environments we haven't explored much yet. The so-called gap in the fossil record might just be because paleontologists weren't looking in the right spots. Our hero of the day wasn't the only cool guy rocking the planet before dinos settled in. Over 500 million years ago, the weirdest predators to have ever existed ruled the oceans. The name is a bit tricky to pronounce, so I'm not going to. Okay, it's Anomalous, but it just literally means unusual shrimp. This creature looked nothing like anything alive today. Scientists think it was the first true apex predator, the orca of its time. Anomalous was massive for its era, as it grew up to 3 feet from its sharp grabbing arms to the tips of its tail fins. For a while, everyone thought trilobites were its go-to meal, but new research shows it wasn't strong enough to crack open trilobite armor. So instead, it was a speedy, agile hunter with awesome vision, and it often picked off soft-body animals that zipped through the open water. Now, another really cool creature from pre-dino times is a fish that could walk on land. Tiktaalik lived in marshy rivers that looked a lot like today's Amazon rainforest. It could grow up to 9 feet long, and it found its prey in rivers and inlets like a modern-day freshwater crocodile. It had a flexible neck and even some early versions of lungs, and thanks to them, it could survive both in water and out of it. Why fish like Tiktaalik started moving toward land about 395 million years ago is still a bit of a mystery. Around that time, the ancient supercontinent called Gondwana was drifting closer to the land that would become North America. This slow movement created lots of shallow, swampy habitats, which were perfect places for crocodile-like animals to thrive. Plus, these areas were near the equator, so they were warm and tropical. But there wasn't a lot of food waiting for them on land, so maybe they moved there for safety reasons. There were fewer predators and better spots to lay eggs there compared to the water. Creatures first adapted to living in open water, then shallow water, then marshes and river edges, and only after a long, slow transition did they finally step fully onto land. Now, how about a millipede the size of a small car and weighing as much as a large dog? This beauty lived over 300 million years ago in what is now England. Back then, during the Carboniferous period, Earth's atmosphere had way more oxygen, over 26%, compared to today's 21%. Scientists used to think the high oxygen levels were the only reason these creatures could get so big. But back then, they found a new fossil from a time when oxygen wasn't that much higher than today. They discovered it purely by accident, when a boulder split just right and revealed one of the most complete and largest giant millipede specimens ever. This one could have lived not just in swampy areas, but also in open woodlands filled with tasty seeds, nuts, and maybe even small animals. There's a chance that this beast wasn't a slow, plant-munching crawler, but a predator that would snap up whatever it could find. After dominating the Earth for about 45 million years, the giant millipedes eventually vanished. Probably the reptiles pushed them out, clearing the way for the age of the dinosaurs. Now, in case you ever wondered what would happen if you crossed a polar bear with the saber-tooth cat, here's the answer. This guy ruled the southern ecosystems after migrating 7,000 miles across the supercontinent Pangaea around 252 million years ago. It had a tough skin like a rhino's and massive canines, perfect for tearing away huge chunks of meat, and it was an excellent runner. Once it got to its new home, in what is now South Africa, it replaced a whole group of local predators. But its glory didn't last long, as closer to the end of the Permian period, massive volcanic eruptions made the weather patterns change and wiped out about 90% of all species. And because top predators are usually big, slow to grow, and not super common, they often vanish among the first when massive extinction events hit. And that's how our guy here went extinct. Our final creature of the day was a dragonfly that lived around 300 million years ago and had a wingspan of over 2 feet, 6 long, spiny legs, and huge, bulging eyes. Meganjura. This 4-winged giant is most likely the largest flying insect that ever lived, and it easily outsizes today's dragonflies, which are its distant relatives. Like modern dragonflies, Meganjura like to hang out in open areas near ponds and slow-moving streams. But unlike today's dragonflies, it wasn't just catching tiny bugs. This guy was likely the top predator in these open spaces. It used the spines on its legs like a flying trap to snatch prey out of the air, including other flying insects, small amphibians, and even lizard-like creatures. Scientists found the first fossils of Meganjura in 1880 in the coal-rich rocks in France. The fossils were incredibly well preserved and showed off the detailed vein patterns in their wings. Scientists think Meganjura grew so huge because it didn't have much competition from vertebrates, and the air back then, during the Carboniferous period, had a lot more oxygen than it does today. That's it for today. So hey, if you pacified your curiosity, then give the video a like and share it with your friends. Or if you want more, just click on these videos and stay on the bright side.